Iya, namanya harus kan bilang. ma'am. Shall we start the session?
Yeah, you can start, ma'am. Pavitra.
Yeah, so we'll wait for another 2 minutes and ask all your friends to.
A very good morning to everyone. I'm glad to introduce our guest, Mrs. Ramisha Rani, completed her MTech in Communication Engineering at VIT Chennai campus. She has secured second topper of the VIT. She has almost 5 years of experience in the field of artificial intelligence. She has worked with various companies like Tata Consultancy Services, Infosys IT Solutions, etc. She has focused much interest in the field of Python, machine learning, deep learning, natural language processing, and data science. Currently working as data scientist in AICL with 5 years of experience, which allowed her to know and to discuss with industry trends, market analysis, and research oriented opportunities. Now I request Mrs. Ramsha Rani to address the gathering. Please, ma'am.
Yeah, good morning to everyone. Thank you so much for the introduction. So, can you make me as a panelist to share my screen? Is it audible?
Yes, ma'am. So I'll wait for 2 minutes, ma'am.
Yeah, yes, ma'am. Okay.
Ma'am, now you are the co-host, ma'am. You can share your screen, ma'am.
Yeah, it's fine. Thank you. Okay. So, is it visible?
Yes, ma'am.
Yes. Okay. Okay. So, good morning, everyone. So, I'm Mrs. K. Ramisha Rani, working as a data scientist in AICL. So, today we are going to discuss the topic under future selection and dimensionality reduction, right? So, ma'am, is there any Q&A option session? Like,
Ma'am, there is no Q&A session. If you want, you
okay,
can
but
put
we
in
have chat.
chat box, ma'am.
So all the participants, you can record your answer on chat so that we can make some interactive session on this, because the importance of future selection and dimensionality reduction is much more important. Definitely, I need some answers from you, right?
Okay, ma'am.
Yeah, okay. Okay. So I hope everyone knows about what is a machine learning is, right? So under machine learning is maximum for prediction, right? So data science is to get another answer. Apart from prediction, we can use data science to get some of the answer for the questions, right? So machine learning is mainly for predictions, right? So under machine learning, there are three concepts, right? Supervised learning, unsupervised learning, and semi-supervised learning. I hope you are all aware about the each domain, right? Do you want any refresh about what is supervised, unsupervised, and semi-supervised, and how model works? Because if you understand what is model and weight, so that only you can easily understand what is the purpose of feature selection and dimensionality reduction. And this is going to be very much important for your research work. If you are doing some research work in machine learning projects, then this is going to be the main plays the important role in your research work. That's why I'm asking you. So you can type in chat box that if you need any refresh of the sessions, like what is model, what is weight, actually what is machine learning is, then I can do some refresh. Then I will start with the feature selection. We have 1.5 hours time so that we can make a good informative session. So if you want to refresh the session, you can type S in the comment box, like in chat box. Okay, I hope everyone aware about what is machine learning is. So I will start with what is the feature selection and the dimensional reduction. Right? Shall we start? Please type S in the chat box so that I can understand that you are all listening. Okay. So I received one response. Yes, ma'am. Abdul sir, thank you for your response. Okay. So anyhow, let me quickly tell you what is model weight and biases, right? So model is nothing but, so first you have to understand what is formula, right? So formula is nothing but, for example, if you take y is equal to mx plus c. So this is a straight line equation. This applies to the linear regression, right? So after the calculation, when you find this weight and bias, okay, the slope and intercept, right? So you will get like y is equal to okay, y is equal to, for example, 5 into x plus 26. So literally I have mentioned the dummy value here. Now this is called as model, because if you want to do any prediction, so that you can substitute the x. So x is going to act as an input. So this is called the model. So this 5 is called the weight and the 26,000 is called the bias. So the purpose of weight is, so how machine learning is possible for future prediction? Because once we find what is the ratio, okay, what is the ratio of the each variable is getting increased or decreased. So if you find that particular ratio, then we can easily do some predictions. Okay. So so that only the weight plays very crucial role in AI world, not only for machine learning, even we follow in deep learning, natural language processing, and in everything which comes under the AI, right? So this is called the model, and the bias is nothing but the initial starting point of the straight line, right? So each term, actually the bias can helpful for to find the very initial value, right? When the input is 0, then bias is going to play the vital role for that, right? So that is our main quick introduction about what is model, what is weight and bias, right? So the topic is the feature selection and dimensionality reduction. So first you have to understand why we have to go for feature selection. First you have to know what is feature. Any idea? So we used to say future is an input. Like, for example, you are doing some prediction. We'll take one problem statement like conquered strength prediction. Okay, conquered strength prediction. Right. So consider a scenario, follow the scenario and try to visualize it so that you can easily understand what is the purpose we have to go for feature selection, right? So we have nearly 30, okay, 30 input, okay, 30 inputs and one output. So successfully you have created a model, okay, successfully you have created a model using just 30 inputs. And everything is good, like you have validated your machine learning using that particular validating parameter and everything is good. But while we are going for implement, understand clearly, while we are going for implementation in real-time deployment, okay, real-time deployment, at the time you have to make the 30 rows. You need to predict that particular value. You need 30 inputs. You have to fill the 30 inputs. So what if the 30 inputs, to calculate the each input, if you want to spend some money, then you have to spend to calculate the each value input for nearly for 30. So just think about how much cost it, right? So a better example, like if you take some any medical predictions like chronic kidney disease, So obviously input is going to be blood report test, right? Like sugar test, BP test, then all the blood kind of reports. Obviously, if you want to make a prediction, that particular person have to go for all the tests and you have to provide that tested output to the nurse, so that the nurse will put on our implementation system, and she will tell, okay, in future you will not have kidney chronic, you will have the kidney disease, like that. So think about, what if we implement all these 30 inputs? Definitely this is going to be the worst case, right? Time consuming, computationally very bad, as well as cost also it's very bad, right? So how we can overcome such type of drawback in machine learning? So instead of creating 30 inputs, so in real time for one problem statement yearly, we can get 500 inputs, like, okay, 500 inputs, then it depends actually based on the problem statement. So creating the model based on all the 30 inputs, all the 100 inputs, this is going to be the worst case of machine learning, right? But in the case of deep learning, understand clearly, in case of deep learning, we don't want to worry about the feature selection and dimensional reduction. Automatically, the deep learning understands a perfect future for that respective output. But only in machine learning, we have to concentrate on feature selection, right? So now we know the purpose of the feature selection. Like, so instead of 30 inputs, okay, what we are going to do is we are going to select only the 5 inputs. Not only 5 inputs, you can go for trial and error method. So for 5 inputs, you are checking what is the accuracy, right? For 7 inputs, you are checking what is the accuracy. For 3 inputs, you are checking what is the accuracy with respect to the output variable, right? So 3, 5, 7. So for example, when you have for 3, you may get a 95% accuracy, 80%, and 90%. For example, I'm just putting these values. Okay, so even for 3 inputs for this particular problem statement is giving the good accuracy level, like 95%. So that instead of using this 30 input, you can use only the 3 input, that important feature. That's why this is called the feature selection. Instead of 30, we have reduced it to 3. Now for the implementation, you just need only the 3 inputs, right? So this is the most important motive of feature selection and dimensional reduction. And now you can ask me one question like feature selection and what is the difference between dimensional reduction? How dimensional reduction differs from feature selection, right? So understand one thing. So what I have told so far, like instead of 30 inputs, you can make for 3 inputs. So that is going to be the baseline for both the feature selection and dimensional reduction. But the procedure will get different, right? So first we'll see what are all the steps for feature selection method. Then I will go with the dimensionality reduction, right? So feature selection method is it selects the important feature among the input features. So what I have said previously, like instead of 30, we are going to select only 5 or 3 and 7. Based on error and trial, we are going to select which input variable is going to give the result. So again, based on the user input. So I'm going to give, I want to see the accuracy for when my input variable is going to be 3 and when for input variable is going to be 7. So this will be based on the user input, right? And there is no change in the data value. So understand this point clearly. There is no change in the data value. Okay, which means for 30 inputs, selectively, we are going to take only 5 inputs. So that there is no data value, only we are reducing the columns, right? So now we'll see what is dimensional reduction, right? So for input columns, there are many names in AI, okay? they used to say that is the input independent variable, then features, right? So another name is dimension. So if it is only one input for the problem statement, then we used to say that is a one dimension. If it is a two input, we can say that is a two dimension. If it is three input, we can say that is a three dimension. So even if we have the 30 inputs, then we used to say this is a 30 dimension, right? So first you have to understand from the name itself what exactly it is. Right? Okay. So when it comes to dimensional reduction, input variable values are converted into cluster. Here we are not going to simply take like feature selection method. Like if you want 3, then it selects based on the performance. It's going to select only the 3 input. But in the case of dimensional reduction, we are going to convert that input into a cluster. So based on the cluster, we are going to find the pattern, the linear pattern, right? So we are going to see entirely in detail, okay, in upcoming session. As of now, just understand what is. Is it audible? Is it audible?
Yes, ma'am. Yes, ma'am.
Okay. Okay. So based on the user input, it's going to select the number of cluster you want from the inputs, right? So the main difference between the feature selection and dimensional reduction is there is a change in the data value, right? There is a change in the data value. So I will show you how feature selection works with the diagram. Okay, so consider this is going to be the 4 inputs. So after the feature selection method, just we have taken size and age. You may ask me the question, how come we know these 2 features is going to give the good result? Right? I will tell you there are several algorithms to select for this respective output. What are the algorithm, what are the input is going to give the better result? So as of now, just understand the overview of how feature selection works, right? So this is exactly we have just dragged the size and age in this after the feature selection method, like 2, right? So the next part is the dimensional reduction. So we'll take the same set of input like 4, but after the dimensional reduction. So under dimensional reduction, there are 3 concepts. One is PCA. I hope you all are aware about what is principal component analysis, the linear discriminant analysis, the kernel PCA, right? So after the PCA process, you can see this is cluster 1, cluster 2, cluster 3, and cluster 4. Is it clear? So here you can see we haven't taken a such from the data set. You can see we have changed our data values. You can see here. So none of the value will match with this data set. So fully based on some sensible calculation using PCA, we have reduced it to 4. So for example, I have taken this screenshot. So for example, you can take only the 2 cluster if you want. Right? So this is the main difference that you have to understand very clearly. So what is PCA and what is feature selection? Okay. So now we'll see the algorithms. Okay, for what is the feature selection method and what is the algorithm for dimensional reduction method. Right? So for feature selection method, we have select algorithm. The validating parameter is fully based on the chi-square and RMS value. Then another one is the recursive feature elimination. So what is recursive feature elimination? I will tell you clearly, and this is based on the each variable with the output. Then future importance. So for these three is for non-linear data. Understand clearly, these three is for non-linear data. Clear? So forward selection and backward selection is for the linear data. Right? Converting multiple linear regression into simple linear regression. Is it clear? So the algorithm for dimensionality reduction is principal component analysis, linear discriminant analysis, then kernel PCA. Right? So the principal component analysis separates by the linear line. Right? The kernel PCA separates by non-linear line. That is the simple difference between the principal component and kernel principal component analysis, right? So first we'll cover the feature selection method algorithm for nonlinear data, the select algorithm, recursive feature and feature importance. Then we'll cover the dimensionality algorithm, how PCA works, LDA, then kernel PCA. So after finishing the theory session, I will walk you through with the hands-on, how you can create the more model with the feature selection, right? So shall we start? Shall we start? Please type.
Yes, ma'am.
Okay. Okay. So now consider this is a data set with the 15 columns. So instead of 15 columns, we want to select only the most responsible and important feature. So the problem statement is this is a data set for the salary prediction based on the 10th pass mark, 12th pass mark, degree pass mark, work experience, specialization, and everything. So based on this, we want to predict the salary. So instead of entering all this value, we can able to create using all these 14 variables. We can create model, but while in prediction, we have to enter all these values, right? So instead of that, we put into a feature selection and we can take only the two columns or three columns, okay, which can easily give the good result for the salary, right? Okay. So first we'll start with select key algorithm. So validating parameters Chia square and RMS value. So now consider a scenario here fully to explain how this particular algorithm works in backend. But in Python coding, this is going to be in one line, right? So this is the input variable 1 and this is output variable. So first the algorithm is going to take only one input, for example, the 10th pass mark, and with respect to the output, it's going to calculate the Chia square. So what is the formula for this? Observed value minus expected value minus predicted value, right? So based on this algorithm, it's giving nearly 0.8. Right? So this is the first step this algorithm will start with. In next scenario, okay, it's going to add, it's going to add the second input. So now we have input 1, input 2, and same output variable, because output variable does not change because it's going to be same for whole the problem statement, right? So now we are going to create a model using these two input, and we are going to check what is the, because since this is a regression problem, so we have to, our validating parameter is, okay, our validating parameter is R square, right? I hope you are all aware about what is the validation parameter for regression and what is the validating parameter for classification, right? For regression, it is R square. For classification, that is accuracy based on the confusion matrix, right? So when we include the another input, when we have the two input with respect to this output, the R square value is 0.85. So in previous case, when we had only one, at the time it's giving you 0.8. Right? So now we have two inputs. At the time, we have increased 0.05% when you include the second one. So now we'll check for the third one, right? So when you include one more input into this, like now we have 3 inputs and one output. So now you can able to see now our R square is, okay, now our R square is decreased to 0.75. So when we include this particular value, our R square value is decreased. So we don't want to use this particular parameter. So this for this, when we use this 10th pass mark and 12th pass mark itself, we can able to get 85% accuracy. So likewise, it tests with all the combinations of input. It adds one by one and it tests respectively with the output, and there will be the comparison with the R square when we use the first one, like one column, second column, and third column. So based on that, it's going to give us. So if we give only 2, so based on this calculation, it's going to select the 2 and it's going to give the best accuracy. If you want to use for 3, if you want to check accuracy for 3 column, then it will give what is the accuracy when you include the 3 columns. Right? So likewise, based on this validating parameter, the SelectK algorithm will start giving you the best feature selection for the particular problem statement. Right? So when we include the 4. So now you can see when you test with k is equal to 4, at the time, you can see your R square value is increased to 0.90. So we have tested with when k is equal to 1, when k is equal to 2, when k is equal to 3. But when k is equal to 4, you are getting the good result. Right? We are getting the good result. So we can fix for this problem statement when k is equal to 4 is giving the good result. So that these 4 is going to be your important feature from that 15 inputs. Clear? So using this, so you can use the SelectK best for classification as well as for the regression. Right? So you can see here. So the another advantage of feature selection is, okay, another advantage of feature selection is you can create more than one model for your problem statement. Here you can see this is the feature selection validating parameter like SelectK best. So based on this feature selection, like based on this Shia square, okay, I have selected, for example, k is equal to 3 feature variables, right? So what I'm going to do is I'm going to apply, okay, I'm going to pass the 3 input features into logistic algorithm, and I'm going to check what is the accuracy for that, if it is a classification problem, right? So again, what I'm going to do is, again, I'm going to pass this 3 input to SVM linear, then SVM nonlinear, KNN, naive Bayes, decision tree, and random forest. So here you can see using this one feature selection method, nearly I have created 1, 2, 3, 4, 5, 6, and 7. Right? 7 models. So based on this, you can select the best performance. So you can tell using feature selection, you can improve your model performance. Model performance. Clear? So for regression, you can see it works for linear, SVM linear, then SVM non-linear, decision tree, and random forest. So these SVM linear, non-linear, decision tree, and random forest is going to be supports for both the classification as well as for the regression. Clear? Okay. So this is all about the SelectK BEST. So the next algorithm is recursive feature elimination. So what is recursive feature elimination? How does recursive feature elimination differs from the SelectK algorithm? Right? So for recursive feature elimination, you have to understand the two important working principles, the two concepts, right? So the first one is, you can see I have mentioned here the machine learning algorithm 1 and machine learning algorithm 2, right? Which means in previous case, we used the chi-square. Okay. But here, instead of this particular validating parameter, we are directly going to use the machine learning algorithm. It may be the logistic. You can test with SVM linear, SVM non-linear, with many algorithms. Right? This is the first important thing that you have to remember for recursive feature elimination. Right? And one more thing, okay? And one more thing about the recursive feature elimination is, this is the first principal module for this recursive feature elimination. Then the second one is, so the second one is RFE, right? So as per the name, okay, as per the name, we have to do some feature elimination. So from the name, you can understand we are going to eliminate the repeated features. Okay, so how we are going to find that this is the repetitive feature and we have to eliminate this, right? Ma'am, do you face any network connection problem? Is it everything okay? It is in flow? Hello, it is audible, ma'am?
Yes, ma'am. Yes, ma'am.
Do you face any network connection, ma'am, from my side?
Nothing, ma'am. Nothing.
Okay. Thank you. So, so again, we are going to take the same scenario, the input one and the output, right? So we are going to apply one machine learning algorithm. For example, logistic algorithm or linear regression algorithm, right? So you can see when you're applying for machine learning algorithm 1, you're getting the R square value like 0.78. For the same set, when you give for algorithm 2, it may be any algorithm, at the time it's giving 0.80. Okay, so you just note down these values, right? So when you add the second, okay, when you add the second input to the model, here you can see there is a no change. There is a no change in the R square value, right? So that we can assume, so this particular algorithm is designed like, if there is no improvement in the R square value, if it is a regression, kindly remove the last added parameter. Because by adding this particular input variable, there is going to be no change in the algorithm. Then this is going to be the repetitive feature, like 10th pass mark, like the first input variable, so that we can eliminate this second call. So likewise, it start adding the one by one and it tests with the algorithm values. If there's any sudden change, let's see on third one, when you include, okay, when you include the third variable, now we are going to create the model using these three inputs, right? So at the time you can see there is a sudden change in the values. So you can see, you can say for first algorithm that is decreased, for second algorithm that is increased. Even if there is a fluctuation like in increasing order or decreasing order, you have to consider this particular column as is going to be the important feature. You should not eliminate this. You have to keep this as a important feature variable, right? So in this way, the recursive feature elimination will start eliminating the unwanted, the repetitive input features. Clear? Clear? So for this particular method, when you use the recursive feature elimination for your work, you can able to create nearly 7x4 models. 7x4 models, so that you can do like some research kind of thing for your project using this RFE. So first I have, because the RFE first rule is it's going to work with the machine learning algorithm as a validating parameter. So consider a scenario, we have selected the future using logistic. Okay, we have selected using logistic and we have to pass, we are going to pass this logistic into a logistic algorithm. Again, we are going to pass this logistic selected future for SVM linear, so that with different combinations you can select and you can get the accuracy. If it is a classification, accuracy; if it is regression, you will get R square, right? For regression, so for regression, we are going to work with only regression, SVM, linear. It doesn't work for non-linear. Decision tree and random forest. Nearly 4x4, which means 16 models. So based on this, you can select which one is working good for the particular problem statement, right? So nearly using this future selection, we can able to reduce the input as well as you can improve your model performance, so that you can give with the various combination, because the in machine learning there is a no rule for this algorithm works better for all the problem statement. So only there is a one rule for machine learning. If it is a linear data, you have to use the linear regression or multiple linear regression based on your independent variable, right? If it is a non-linear, you can check with SVM linear, SVM non-linear, decision tree, random forest, and with all the algorithms for one problem statement. Clear? So with curiosity, we'll start checking with automatically. Once you understand the purpose of machine learning and how it works, automatically you will start checking for various combinations. What if I put this random forest with decision tree? So like that, you will start searching for the best accuracy. You will start searching for how I can improve my accuracy. What if I check put with these combinations like that, right? So the third one is the future importance. So how this future importance differs from recursive feature elimination. So recursive feature elimination, it start checking with the important algorithms, machine learning algorithms. If there is no improvement in the accuracy when we add any of the input, we are going to remove that particular input variable. So future importance is, from the name you can understand clearly. Okay. So y is equal to formula, for example, x1 w1 x2 w2 plus x3 w3 x4 w4. This is a formula. So after the model, okay, we have x1 3 plus x2 0.2 x3 5.2 like so on, right? So from this for this particular input 3, we have highest weight like 5.2, so that we can consider this particular one is going to be the important feature. So second feature is going to be when x1 is equal to 3, which means for input 1, our weight value is 3. So this is going to be the second important one, and this is first, and third one is 0.2. So if you are giving for two selection, then the algorithm will start select for 1 and 2, which means input variable 3 and input variable 1 based on the weight value, right? So you can use any algorithm you want, right? You can use any algorithm you want. The variable selection is purely going to be on the weight. So this is going to be the normal for future importance. But the one thing you have to understand for future importance is the permutation. So using permutation concept also, we can create the future importance. So how the permutation works here? So it will start first to select with the input feature 1 and output variable, right? So input variable 1, it start exchanging the values like row wise. So it start exchanging the rows and it start calculating the R square with any machine learning algorithm, right? Any machine learning algorithm. So without interchanging the rows, it calculate what is the accuracy. After interchanging the rows, what is the accuracy? So if it is any sudden change in the accuracy or an R square, it start considering that is going to be the most important feature. So this works purely on permutation, right? So in future importance, that is going to be the two important thing. One is you can use any algorithm, right? Machine learning algorithm. So based on the developed model, you can select for which one is giving the best weight. Based on that, you can select the important feature. The another one is permutation concept. So permutation concept is nothing but it start exchanging the row values, right? Okay. So far we have completed the feature selection method, right? Select K best, then RFE, recursive feature elimination, then feature importance. Now we'll quickly go through what is dimensional reduction and what is PCA. Okay, so to understand this dimensional reduction, first you have to understand what is the scalar and vector, right? Do you have any visualization for scalar? So we all know whenever we ask the question about what is scalar, we used to say there is a magnitude. If it is a vector, direction and magnitude, right? How you can map this physics term to the data science, right? So if it is a scalar, we know that is a magnitude. So here you can see if it is 10, okay, if it is 10, you can see the magnitude size is little bit increased compared to the magnitude size of 5. And you can see the comparison for each value and their respective size. So magnitude is all about increasing, okay, increasing or decreasing the size. Even if we decrease, even if we increase, we used to say that process is going to be some magnitude, right? So how this is going to be helpful for data science world? How this is going to be helpful for natural language processing? Because in natural language processing, we use a lot of vectors. So you have to understand what is vector clearly, right? I hope now you understand what is the scalar, right? So now a vector. So vector is magnitude and direction, right? So for example, you can see here when magnitude is 5 and direction is right side. So that I have given this arrow point towards the right side. Clear? So the second one. So when the magnitude is 10 and direction is left side. So you can see when magnitude is 5 and when magnitude is 10. There is a vast difference in the size. So when magnitude is 10, you can see there is a sudden increase in the size. And direction is towards L. So when one particular scenario works based on the magnitude as well as the direction, you can say the particular action is fully based on the vector. Clear? So here you can see the various magnitude and direction. Okay, so for as per the name, we have visualized how it works. So in mathematically, how this is going to work. So we used to know how to plot the 2D graph, right? So we are used to plot the, for example, 4,2, 3,2, 1,1, like that. So this is nothing but, for example, 1,1, and this is 3,1, right? So you can see here, this act as a vector. So when you have two things, okay, when you have two things, more than one, you can say more than one. If it is only one value, we can say that is a scalar. If you have more than one value like 1,1 or 2, 3, 4, we can say that is a vector. Because this vector is giving you the distance, right? Which means the magnitude as well as pointing towards the first quadrant. Clear? Here you can see the magnitude is little bit increased compared to this one, right? And there is a sudden change in the direction also. If you take angle between these two, you can see there is a change in the second point. Right? When you have 2 points only, you can able to make such kind of direction. If you have only one, you cannot able to give you the direction. Right? So for example, consider you have 4 quadrants and one point is over here and another point is here. So we can say this is a positive quadrant, like first quadrant, second quadrant, third quadrant, fourth quadrant. So for example, this is going to be the negative side. So for example, -3, -3. So it pointed towards the downward direction and the magnitude is this much, right? So I hope now you all know what is the scalar and vector. So how the scalar and vector helps for dimension? So how many dimensions are in this world? So can we be able to visualize the 0 dimension? So the 0 dimension, like one dot. It doesn't have any measurement. We don't have any value to represent this G0 dimension, right? So if it is one dimension, okay, we can represent like this. Okay. If you want to represent in value, we can say that is 1. If it is 2 dimension, we can represent like this. So 1, 1. It may be any value over here. For simplicity, I'm using 1, 1, right? So how the third dimension will look like? Right? The third dimension, 3 dimensions. So we are in 3-dimensional world so that we can able to experience up to the 3 dimension. 1, 1, 2. Is it audible? Is it audible, ma'am? Hello. Okay, thank you for the response, sir. Okay. So if it is n dimension, we can represent like 3, 4, 5, 6 for 5 dimension when n is equal to 5. 100, then 150. Likewise. So for n dimension, we cannot able to visualize it, but we can represent in the mathematical form, in number form. Okay, so now we understood what is dimension. How we can, okay. So how we can map this dimension to the data world. Because this is going to act as a column 1, column 2, column 3, column 4, column 5. That's why this is the n dimension. That's why if we have more than lot of numbers, more than 3, we used to say that is a dimensionality course in machine learning term, right? So we used to say when it involves more than one value, we used to say this is a vector, right? We used to say this is a vector. We cannot able to visualize it, but this vector is going to give you the direction as well as the magnitude, right? So now we'll start with the principal component analysis, because principal component analysis maximum work with the eigenvalues and eigenvector. Because if it is the eigenvalue that represents the scalar, if it is the eigenvector, obviously it represents the vector. So that you have to understand what is the scalar and vector, how this is going to helpful for the principal component analysis, right? So now consider we have plotted the input data, right? You can see we have plotted the input data in a two-dimensional, right, in 2D. So the first process in principal component analysis is we have to convert this input into a covariance matrix. So what is the covariance formula? Nothing but if we have the two inputs, right? Input 1, input 2, then input 1 will have the mean value and input 2 will have one mean value. So we are going to subtract each value with respect to the mean. So by doing so, we cannot able to reduce the distance between these 2 points, but we can drag this whole data set which passes through the origin. We can able to drag to the center because we are going to form cluster. Okay, we are going to form the cluster. Right? So after the covariance matrix, here you can see we have dragged the data towards the origin. So when it passes, all the data passes through the origin, you can make the possible lines, line 1, line 2, line 3, like so, right? So this particular line is our first component because this acts as a regression line, and most of the line, okay, we are going to start calculating the distance between this point and the regression line. So by placing which line it's going to give you the minimum error, we can represent that as a first component. So second component rule is this should be exactly the 90° to the first component, like this. This is our second component. So now you visually understood how the principal component, I told this works fully on the cluster and there is going to be the change in data value. When we take the covariance, obviously we are changing our whole data set which towards the normal distribution. We are converting that towards the origin. So the second concept is we are going to take from the cluster. So randomly we are drawing this line. So I will tell you in mathematically how we can able to find this first component. Right? So these are the diagrams. When it passes through the origin, you can able to make how many clusters you want. Clear? Okay. So far we just overall understood how PCA works. First it should need the covariance matrix. Based on this covariance matrix, it drags through the origin. So based on the origin, it's going to select the component 1, right? The principal component 1. So how we are going to implement that in mathematically? Right? The eigenvalue and eigenvector. So to understand this concept, I have taken the screenshot of the calculation. First step is there is a data set. We are going to put all the values into covariance matrix. So after the covariance calculation, for that covariance matrix only, we are going to find eigenvalues and eigenvector. Okay. So consider this is column 1, column 2, and column 3. We have three rows. So here we are taking very simple data set. Consider this matrix as a data set. Okay. Just understand the principle how eigenvalues and eigenvector helps in PCA, right? So this is going to be same concept for even if you work with the hundreds of input and thousands of rows. Clear? So the first thing is we have to find the value, eigenvalue. So based on this eigenvalue, we are going to find our eigenvector, right? So what is eigenvalue? So I hope you are all aware about the formula. Already we have studied in our 12th grade, I think so, as well as in the college. So this is the formula, determinant of A particular matrix minus lambda into identity matrix is equal to 0. So as per the calculation, okay, we can able to get like the diagonal matrix. In this diagonal, we have the lambda value. Right? So based on this matrix, understand clearly, based on this matrix, we are going to find, if it is 3 columns, then we will get the 3 eigenvalue, lambda 1, lambda 2, lambda 3, right? So first, after some several calculation, the lambda 1 value is 0, lambda 2 is 2, and lambda 3 is 4, right? So based on our data set, consider, understand clearly, based on the data set, we have calculated in a logically the 3 scalar value, eigenvalue. If it is a scalar, automatically in your mind, indirectly, it's telling that it's all about the size. So the first size is 0, the second size is 2, and third size is 4. Right? So now we'll, based on this eigenvalue, now we are going to find the vector. So using the same formula, but here don't need to take any determinant. Clear? So when lambda value is equal to 0, we got the vector, okay, we got the vector as -1, -1 and 1. Clear? -1 and 1 as the first vector. This vector purely belongs to scalar value 0, right? So now when vector lambda value is equal to 2, at the time you are getting the vector as 1, -2 and 1. Clear? So this is the vector purely belongs to when lambda is equal to 2, when the size of the scalar value is 2, the respective vector. So the third vector is 4, right? Value is 4. The respective vector for scalar value 4 is -3, -5 and +3. So now we have eigenvalue 0, 2 and 4, and respective eigenvector is -1, 1, sorry, -1, -1, 1, -1, -2, 1, -3, -5 and 3. So when we talk about the scalar, okay, when we talk about the scalar, I already told magnitude. If it is magnitude, then we have to go for the size. We have to look for the comparison size. And how you can relate the size with principal component. So component analysis, not a comparative word, right? But the principal component, but principal word is a comparative word, which tells that the most important, that when we say that is the principal, it gives you the most weight. So this principal component analysis is fully based on the comparison concept. So when we have comparison concept, then exactly it matches with the scalar. So now tell me, in this 0 to 4, which one is the principal value, which means the highest value, highest size value scalar? That is 4, right? So this 4 exactly represents the which vector? -3, -5, 3. then this vector is going to be PCA1, principal component 1. Then this is going to be PCA2, and this is going to be PCA3. Only we can able to get the 3 components if it is 3 scalar value. Based on this, you can go for 2. Clear? Now you can see how we have changed the value, scalar, which means the data value. We are going to work with this value as the input features. Is it clear? Can you able to visualize that how we have compared the eigenvalues and eigenvector in PCA, why they have named this as a principal component, and how this eigenvalue helps to find the principal component with the respective vector. Is it clear?
Yes, ma'am.
Okay, okay. So the next concept is a linear discriminant analysis. So here you have to understand what is the exact difference between the PCA and LDA. So from this name, you can understand what is, this is linear. We already know if it is linear, that is going to be the straight line with the slope, right? If it is the discriminant analysis, discriminant means something difference. We are going to see the difference. The analysis, we know what is the meaning of analysis, right? So with this diagram, you can easily understand the quick concept of what is linear discriminant analysis. So here we have 2 classes like rectangle, triangle and circle class. So after LDA, after linear separation analysis, we can segregate the circle class and the triangle class. So this particular algorithm mainly works for the class separation. Okay, I can say PCA for the regression problem statement and LDA for classification problem statement. So here you can see this is LDA1. If you segregate these 2 classes and if you take the probability distribution function for this each classes, you can see this is well clearly segregated. But if you are seeing, okay, if you are seeing in this perspective, in this axis, you can see that is overlapped with 1. So this is going to be this LDA1 is going to be the effective segregation for this particular class, right? So this is the working principle of how the linear discriminant analysis work. Exactly, if you know how cluster process works, exactly the same, right? Based on the centroid, it start working. Okay, so here you can see this is a labeled data. Principal component analysis, PCA doesn't look for is there any classes there, whether we have to segregate those. So PCA doesn't care about the class. Only it cares about the distance, the variance of the whole data set, maximizing the variance of the whole data set. But the LDA maximize the distance between the 2 classes. Automatically for the same data set, if you apply LDA, it starts segregating the 2 classes with the maximum difference so that we can easily classify our data. Clear? So if it is kernel PCA, you can see if it is simply the PCA, we are going to use the linear line. If it is the kernel PCA, based on the data pattern, the best fit line will get differs. So this is how each algorithm differs from one another, right? Is it clear? Okay, quickly I will walk you through with the code. Okay. So first we'll see for select k best. I have created a code for select k best which supports for the regression as well as for the classification. First I will take the classification code. So what I have did here is I have made the reusable code, right? So here I have simply created the algorithm, select K based, then how to split our data set, and for confusion matrix. Like I have created everything into a function so that I can easily call wherever I want that particular process. Then in this one program, I have defined for logistic SVM linear, SVM non-linear, naive Bayes, KNN, decision tree, and random forest. Then the final tabulation, what I have shown in the PPT, exactly I have developed here, right? So up to this is going to be the functions procedure. I can say function is a set of procedure, what calculation we have to go, right? So let me run this first. So here I have taken a problem statement of chronic kidney disease prediction. So first I will show you how the data set is looking like, right? So data set 1. So we'll go to variable explorer and we'll see. Here you can see the size. 399 is the rows and 25 is, okay, 25 is number of columns, the input. So since this is a medical problem statement, we cannot able to train with all the inputs. You can see here, age, for calculating age, no need to spend any money, but for checking blood sugar level, then this is albumin, kind of white blood cells, red blood cells, sodium, packed cell volume, all the variables are in a medical term. See, this is the data set. We have both the numerical as well as the categorical. Right, nearly we have 24 inputs and 1 output. Clear? So the second step is, okay, the second step is we have to convert all the categorical data into numbers. I hope you are all aware about the pre-processing technique, how you can convert the categorical into the numbers. So again, the categorical differs, comes with the 2 different module. One is the nominal categorical value, one is ordinal categorical value. If it is nominal, you have to go with one hot encoder. If it is ordinal, you can simply go with the label encoder, right? So using most of the columns here is the nominal, right? So if it is nominal, you can say we cannot able to compare the values. So let me show you after the one hot encoder how this data set is looking like. So now you can see there is no categorical value, right? There is no categorical value. So we have converted everything into a number so that now we are ready to go for the calculation part. Right? So the second step is I have taken a, we have to take the independent variable, which means the X input and Y input. In this, only the classification S is going to be the output variable. So to take only the input, I'm going to drop that particular column. Dependent Y is output variable. Only I'm going to take that classification column. So let me run this. So here I have taken, here I have called the select K best algorithm, what I have already defined here. What I have already defined here. Clear? So here this file, so this tabulation is going to be for when K is equal to 5. Right? So here I have created the empty list to store the respective calculation value, right? Then initially I have splitted the data set into X-train, X-test, Y-train and Y-test, right? I hope you are all aware about what is the purpose of training set and test set. So we create model using training set and we test with the test set. right? So here you can see, here I have called the logistic regression, SVM linear, SVM non-linear, KNN, naive Bayes, decision tree, random forest. Finally, I have created a table. So let me run this. So finally, you can see I have created in this one program. Okay, in this program, I have tested with all the possibles. So I have tested with the logistic regression, SVM linear, non-linear when k is equal to 5. So now if you want to check for when k is equal to 3, you can replace k is equal to 3 and you can test with the same process. So now you can see when I changed to 3, you can see there is a sudden decrease in the variable. So when k is equal to 3 is not working. So let's check for 7. Okay, we'll see what are the values we are getting for when k is equal to 7 when we choose the 5 important variables. Now you can see maximum it's giving the good value nearly 97, 97, 97, 98. So based on this trial and error, you can choose your model performance. You can select your best, right? And this is the select K for classification parallelly. So in this, after the if you take any problem statement and if you have done with pre-processing, then you can, after pre-processing, only thing is you have to load the data, you have to assign the independent variable and dependent variable. Then this one click of this particular code is going to give you the several result, right? So go to files and I'm going to show you for regression. So if you're working with the regression problem statement, instead of confusion matrix, we used to go for the R square value. So here I have created for R square, right? Then for regression, it supports for linear, SVM linear, then SVM non-linear, right? Decision tree and random forest. Finally, the table part, right? So again, to explain the concept, again, I have used the same classification problem statement. So if you are having some regression problem statement, you can use the regression problem statement input, right? So next for the recursive feature elimination. So again, I have created the two inputs like RFE selection, RFE for classification, RFE for regression. Here I have changed, instead of select K, I have applied for RFE feature. So I have made everything into a small function. Again, the same concept. So let me run this once. So this SVC alone, it's going to, it's load for nearly 10 minutes. So finally, what output I have shown you here. The same, like this, I have created the code like this, final output, so that you can change with your K value. What is the, when you are getting K is equal to 3, what is the accuracy you are getting when K is equal to 5, and K value is your playable parameter. Right? So quickly, I will show you the PCA, how the PCA values got changed. Okay. So let me take a separate console. So this is the code for PCA, right? Still I haven't created like check with all the algorithms, just here to understand how this PCA works with the logistic regression. So if you understood the working principle and already you have some hands-on experience, you can create how we have created table for the RFE and select K. Like that also you can create for PCA using PCA, because if you are in a research field, this is going to be very helpful for you. Okay, so here we have taken Wine data set, right? Let me run this. Okay, we'll see how this data set is looking like. Nearly we have 14 inputs and 178 rows. So training and test set, standard scalar, right? And here we have used the PCA. So here we are giving n component is equal to 2, right? Then when it comes with the fit, automatically the calculation will take place. Up to this, just it loads the procedure, right? Let me run this. Right here, now you can see after the PCA, the X train and the X test value is entirely changed, right? But in, okay, let me show you. So this program ran successfully. Let's see the results. So here you can see, right? So this is the future selection method. So I have given 7 without changing any data value. It selected only the best 7 values, right? But if you see for, okay, but if you see for PCA, X train, we have mentioned n component is equal to 2, so that it created 0 and 1. So this is our principal component, 0 and 1, 2 component. Now, the thing is, we are going to apply that X train and Y train into the logistic regression. So again, you can test this PCA with logistic regression, SVM linear, SVM non-linear, and with all the algorithms you want. Right? So for any doubt, so I hope the session is very useful for you, because I felt personally when I'm preparing the content for this, I felt this is the most important thing for the research field if you're doing PhD work. So if you have any doubt, you can ask me now. So we have 3 minutes time. So we have covered what is feature selection, what is the purpose, then how dimensionality reduction differs from feature selection, right? And the thing is, if you are working in nonlinear data, must you have to check with the feature selection as well as with the dimensionality reduction, so that you can able to have the best model for the real-time deployment. Clear? So any doubts so far? So on tomorrow's session, I'm going to take the recommendation system with the hands-on. Okay, if you have any doubt regarding today's session, you can ask me now. Any doubt? You can raise your hands also so that I will unmute you. You can ask your question. Okay. Ma'am, shall we wind up the session, ma'am? Hello, ma'am. Is it audible? Hello, ma'am. Shall we wind up the session?
Yes, ma'am. Thank you, ma'am. Thank you.
Thank you. Thank you, sir.
Thank you. Thank you. We will start the next session by 11:45. Thank you. After 15 minutes break.
shall we start the session?
Hello, Pavitra? Pavitra?
Ma'am, shall we start the session?
Yeah, you can start.
A very good morning to everyone. I feel immense pleasure to introduce our guest, Dr. Anand Harindran, is working as an associate professor and head of computer science engineering department at Muthoot Institute of Technology and Science, Kochi. With over 10 more than years of experience, he has been teaching in various engineering colleges in the state from early 2010. He also has ample industry experience and has handled various technical roles in software development cycle. He obtained his PhD from University of Kerala on the area optimization of association rules. He has obtained 3 IPR in algorithms and has authored 4 books. He has modest number of research publications in reputed journals and conference proceedings. He is a reviewer of many international journals and conferences. His research area includes machine learning algorithms, nature inspired computing, data mining, optimization, health informatics, and product development. He is a research supervisor in computer science and under APJ Abdul Kalam Technology University. He is a member of the advisory board of many colleges across the state. He also holds many consultancies and funded projects from industries and research centers. Now I request Dr. Anand Harindran to address the gathering. Please, sir.
Hi all, thank you for that introduction. So I think we can directly move to the session. So I will just share my screen. Just let me know whether it's visible. Okay, thank you. Is the presentation visible?
Yes, sir.
Okay, thank you. So today I will be basically dealing on the session rule mining using Weka. Okay, this is actually a very advanced topic. I'm not telling it's an advanced topic. It's a very basic topic from where we actually came to something called AI, machine learning, deep learning, CNN, etc. So whatever be the branch, let it be AI or machine learning, if you correctly point out and if you correctly think about the content, you can see that AI and machine learning are not new areas. They are actually a subgroup of data mining. And what exactly is data mining? Data mining can be treated as a subgroup of statistics and probability, and it actually is a subgroup of mathematics. Okay, fine. So we can say that say AI, machine learning, deep learning, yeah, we have a lot of techniques and applications coming, but everything has started with a perspective from the mathematics itself. So today I will be dealing with something called rule mining. I will be showing some examples and a open source tool called Weka. So we can just try out what are the things that are basically intended to do in this particular session. So starting with rule mining or rule learning. Actually, this is a very popular and well-researched method for discovering interesting relationship between various variables in a large database. So what exactly do you mean by variables? What exactly do you mean by interesting relationships? You can see that the same principle that almost all the multi-million companies employ now is they actually play with our data, right? So we all have familiar with the process where our search history is being included. It has been analyzed by some third party agency and they are giving us the basic advertisements and suggestions, right? So all these things actually come from the data that we provide to the internet. So nowadays we actually say that even if you do a crime, you can actually wipe off all the evidence, but not the digital evidence that you have left over there. You will be having your mobile phone. It actually tracks your, it will be actually geotagged. It actually shows where you are. You will be going through using a Google Map, or you will be using some sort of SMS, WhatsApp, or Facebook. Everything what you do is actually capturing data. I don't know whether you have checked out or not. Recently, Facebook was having a particular update. It actually asked you who is your nominee after your death, which means that even after our death, our account can be actually manipulated or can be actually handled by someone who we nominate, which means even the Facebook is interested in a life after our death too. Okay, so that is the power of data, or that is where actually the data scientists or data analysts are actually thinking. They are not only not only want our present data or our past data, they are actually looking for the data even after we pass us on. So that is the importance of data in various fields. So even though I'm having a lot of data with me, it is my need, or it is my basic intent on how I process the data. The data processing can be on various heads. So today we will be learning on how we are generating rules from the data that we provide. Rules may be any simple rule. Okay, saying yesterday they were raining, today is raining, so there is a chance for rain tomorrow. That is a rule. Okay, John bought a new car. John bought a new bike. So there is a chance that John has become rich, on a very recent time. Might be he got some extra amount of salary, or maybe he got some other financial aids. So anything can be ruled. Whatever you see around, you can actually find a relationship between those things that you find around, and you can come to a conclusion. So that is actually what we mean by rule mining or rule learning. So this process of capturing the data and integrating them and finally coming to a conclusion is what we are basically intended to do. So coming to what exactly is learning. So learning can be a process where a system improves performance from experience or environment. Okay, so consider I am having two words. First one is called learning. Second one is called natuto. Okay, if I ask whether there is a word like learning, yeah, everyone will be aware. Yes, there is a word like learning. I know what exactly the meaning is. But if I ask whether there is a word like natuto, you will be confused. Oh, whether is there a word like that? Is that actually English, or is that a word in some other foreign language? So what we can say is, so if for your information, let me tell you, Natuto also means learning, but in a foreign language called Tagalog. Okay. So from now onwards, after the session, if somebody asks you, do you know what Natuto is? You can say, yeah, it also means learning in another language, in a foreign language. So what has happened now? You have improved your performance from an experience which I have shared. So that is what exactly is called learning, or the process of learning. So there are a lot of algorithms to generate these rules or come to some conclusions, or generate some analysis. So some of the basic algorithms that we use, first one is called a priori algorithm, which everyone will be knowing about. The basic algorithm that we normally learn in any data mining course. Then we have FP growth algorithm. Then we have something called ECLAT algorithm and Tertius algorithm. The last two algorithms, okay, you might not be much familiar with, but the first one everyone might be familiar, and FP growth also you will be familiar. So I will be detailing the first two algorithms on in order to explain how the algorithm works. As it will be familiar to you, it will be more easy for you to relate. That's why I'm selecting that two algorithm. I will also tell about ECLAT algorithm and Tertius algorithm. Also, there are a lot of algorithms like tree mining algorithm. Then we have STD algorithm, say smell detection, SDA algorithm. A lot of algorithms are there. So we will be checking each one of them, and we will be trying how the process actually works. Okay. So moving to the a priori algorithm, it's a very basic algorithm developed in late 1993 by Agarwal and Srikanth. It was actually a very innovative method in order to find association rules on larger databases. So it actually does a bottom-up approach in order to find the frequently coming data, and from those frequently coming data, the rules were generated. Everyone will be aware about the AI system right now, artificial intelligence. So consider that I am developing a AI system. Okay, this AI system actually helps you to drive a car. Okay, it is not, I am not ending there. It actually helps you to drive a car. Even if you close your eyes, the car actually leads you through the exact path you want. You don't need to open your eyes. You can sit in the car, you can close your eyes, or you can blindfold. You can just tell the car that this is the place that you want to go. Okay, from your place, I want to go to Chennai. Okay, so, or I want to go to Pondicherry. So the car exactly takes you to the final destination. You can sit in the car. You don't need to worry about the traffic. You can sit, you can eat, you can play, you can see well, watch laptop, watch movie, anything you can do. So I am giving you a system like that. You are installing it on a car, and on the first day, I am telling you, yeah, I'm a very good developer. I developed the system, and I am very much confident. You can actually drive the car. If for the first time when you get into the car, will you actually close your eyes and sit, trusting that I am the developer? Or will you actually stay in the car saying that, yes, yeah, my friend developed it and I am sure that it works well? No, right? There might be a small percentage of speculation whether it goes correct, or is there any issue with this. Even if he tells that it takes the car to a final destination without hitting or taking any other issues, uh, whether will there be any issues? You will be confused. But there is a new stream in artificial intelligence called XAI, which is called explainable AI, which actually tells you why the particular system works like this, or how the system works like this. So it actually tell you, don't worry about the particular software that is being installed, because I am having so and so sensors in my front. If any vehicle comes close, I will stop my car. Or if any vehicle comes, a particular alarm will come or a barrier will come in front of the car, making sure that nobody hits your car. So if the system was able to explain to you why you should trust the system, then it will be more easy. Okay, so you will be fine. You will be very much convinced. Okay, I know that it's not because my friend developed, but because the system actually is doing so and so. So if something comes, the sensor comes, and there is a barrier in front of me, nothing hits me, I will be safe. So I have sensor all around. I have cameras. I will be checking the road. The car actually moves according to the dimensions, or checking how width the road is, everything. So that is called explainable AI. So whenever you are dealing with explainable AI, what actually is doing, you are actually working with data, or you are actually playing around with data. All the data that you feed will be taken by the system, and it will actually give you a particular explanation why it is so. So what? So a priori algorithm was one of the first system that actually took data from that and came to this particular conclusions. So there are various applications, one basic application of a priori algorithm is called market basket analysis. Then we have marketings for fraud detection and for shelf planning. So what do you mean by market basket analysis? Market basket analysis basically tell how you can improve the sales of a particular shop by taking the data of the purchases made by some customers. Okay, so um, one we can see a simple example. Uh, what exactly is market basket analysis? I am going to a particular shop, okay, or I am actually opening a new shop. It's a roadside food truck. Okay. In that food truck, when I am opening this particular shop in a particular city, I came to see that from 10 o'clock in the morning to say 3 o'clock in the afternoon, there was not much sales. But there was high sales during 12 in the noon to 1:30. All other time, I hardly had some particular customers. But after 4 o'clock till 8:30 in the evening, I was getting heavy rush. Actually, this particular pattern continued from Monday to Friday. On Saturdays, I was having rush all through the day. From morning till night, I was having heavy rush. And Sunday, I was having rush only in the afternoon. This pattern continued for the next 3 weeks. So on the fourth week, from these analysis, I will think like, okay, why should I open my store in 9 o'clock and wait till 12 o'clock to have my first customer? I can open in 12, right? I can open in 12 because my first customer comes always in 12. So why should I waste my time? And after 1:30, I could see that next my customers are coming at evening 4. So why should I waste from 1:30 to 4 in my shop simply sitting? So from all this data, he came to know that the rush was due to the people who are in the office actually comes out for the lunch, and when they're getting out of the office, they came through them. So in between time, it was no rush. But on Saturdays and Sundays, they were on off, and they could actually come to my restaurant and they could explore the food. So what actually happened here? He's actually collecting the data of the sales and he's actually making some rules. Likewise, if you go to a supermarket, he actually sees that, okay, the amount of rice that has been sold is high on month beginning. So from 1 to 5 date, month beginning 1 to 5, there is a heavy rush of people who is buying stuff from my home. So I can see, so I can use such promotions in order to, so I can stock more of that particular product and make sure that the sales are being in a very high, going in a very high area. So similarly, I can use the same thing for marketing also. So in marketing, the people, whenever you go to Amazon or whenever you check out eBay or Flipkart, you check for a particular notebook or a textbook written by a particular um, author, say John. You're looking for a book, mathematics book written by Mr. John. Once you have checked Amazon and when you come back to your Instagram or Facebook, you can see the advertisement of all the books written by John, which you will be interested on, or the books on mathematics or the topic which you have looked. So that is also online marketing. It is also used for fraud detection. So consider that I am a person who is living in Kashmir. Okay, and one day, fine morning, when I just started my Facebook or when I checked my email, I could see a particular mail saying that, are you interested in buying a refrigerator and a AC? Okay, and I have offers, so and so. Click the particular link. Is that a fraud mail? Yes, it is a fraud mail because you are on Kashmir, which hardly wants a refrigerator or a air condition in your room or in your house. But if you were in on the southern part of India, where we have extreme climates, a advertisement of fridge or air condition will not be a spam message or will not be a spam mail for us. Why? Because we need to have those items for our day-to-day life itself. So even we are having, we can use these data for fraud detection too. Also, it can be used, the same algorithms can be used for shelf planning. Okay, I'm having a supermarket. I organize my shelf in such a way that the first place I will be putting all the eatables, then I will be going for some canned foods, then some bottled drinks, etc. So what is the advantage for this? The basic advantage is whenever you stock items like this, the customers will be more pleased, or they will be having more choices. For example, if you place a full row of Pepsi in the first counter, and you place the Coca-Cola on the third counter on the second left portion, and you put a Mountain Dew or 7-Up on the eighth counter on the seventh queue, the customer will think, okay, fine. When he go for Pepsi, he wanted 7-Up, so he need to walk around. So after two times after roaming around, he thinks like, okay, fine, I can go to another shop and get all these things where everything is placed as such, and it actually increases the profit also if you arrange the shelf in a very good manner. You keep your bread, you keep your milk, you keep your butter, you keep your cheese, jam, everything nearby. Person who is buying bread, he may or may not need jam, but just having a product nearby will actually tempt him to buy that. So that actually is a shelf planning. That is also an application of such algorithm. So we can see a small example where how we are basically generating rules. Consider that I'm having a particular shop, and in the shop there were 25 customers coming. And the first customer bought some particular 5 different items, say biscuit, bread, cheese, coffee, and yogurt. And the second customer bought bread, cereals, cheese, and coffee. Likewise, I have data of 25 different customers. I need to find out which all items were the most commonly picked by the people, so that next day I can store more of that particular product, which will increase my profit. So for that, am here using a priori algorithm. First, what I did, I wrote all the unique products and I wrote the frequency. Likewise, in how many people have bought biscuit or how many people have bought bread. So whenever you have a first level frequency of single items, you could see that, okay, a bread, 13 people have brought bread, 11 people have brought cheese, 11 people has also bought juice, 10 people bought donut and cereals. Only one person have bought pastry, sugar, which means that on the next day, will he be storing more bread or will he be storing more pastry? Obviously he will be storing more bread. Why? Because the frequency was higher. So now he want to check, okay, let me check what all things went in pairs. Okay, so what he will do, he will take the pairs, so bread and cereal, bread and coffee, bread and cheese, almost all the pairs he will take, and he will check what is the frequency of that. So whenever he checked that, he could see that bread and cereal went 9 times in together, where donut and juice also went 9 times in together. Cheese and coffee went 9 times in together. But when you were considering the single one, they were not in the high priority list. But now, when they were combined, their purchasing rate was increased, which means that it gives the shop owner another insight. Okay, if I buy only bread and keep it, okay, 13 people will buy. Okay, that will give me a profit of 100 rupees. But if I buy and keep bread and cereal together, then people are taking that, I'm getting a profit of say 200 rupees. So that is a better scheme. So what happens, he actually took the frequency of single item, then he took the frequency of 2 items, and so on, and finally he actually arrived at some particular rules or some particular learning, which say that people who bought cheese actually bought bread, or people who actually bought coffee bought cereal. So likewise, he can generate rules. This a priori algorithm actually provides a platform for the particular shopkeeper in order to generate or in order to get such interesting rules. Okay, so how the particular algorithm is being implemented, we can see in the later part of the presentation. So how the basic a priori algorithm works. It's we need to have a database with larger transaction, and it's actually employs breadth first search, and anti-monosity and downward closure are the two properties that a priori algorithm needs. And first we need to find out the minimum frequency in a given transaction and extend this by adding one by one item and repeat the particular step until we have got all the frequent items. The Same method that we have just seen in that particular example. So I'm having sold a lot of items from I1 to I5, and there are various transactions. So here I am having two different terms called minimum support and minimum confidence. I will tell about that in the coming slides. So here also what I am doing is I am finding the frequency of single items, and I am finding the frequency of two items. So now comes the support. So we told that in the first example, 13 people bought bread and only one person bought pastry. So what is the number of count I should be basically interested, or from which count onwards I think that it is highly occurring? That count is called the support. Okay, so if I think that okay, any transaction having more than 6 will be treated as a high priority transaction. So that 6 is the support count, support of the particular transaction. Okay, so here I am taking the minimum support. So 2 is my minimum support. So all transaction which is appearing only one time will be removed, and I am getting the 2 item set. After getting the 2 item set, I am comparing and getting the 3 item set. So and finally I am reaching a situation where I am having the frequent item sets I1, I2, I3, and I1, I2, and I5. So from these 3 item sets, I need to create the rules or generate the learning series. So how the learning series are generated? For that, I need to check, I'm having 3 items, right? I1, I2, I5. I need to check whether I1 and I2, a person taking first product, and I2, second product, will he take I5 also? I'm checking that. For that, I need to have another one that is called the confidence. Confidence means it is my assumption or my probability that he will take, okay, 70% of the people who take 1 and 2 will take 5 also. So I need to have that particular probability or a confidence. So I'm just, for any application, we can actually select the particular threshold. So here I am selecting as 70%. So likewise, I am checking for the rules for R1, R2, and R3, and checking whether this particular final confidence rate is above 70. Only those with above 70 we will be taking into consideration, and others we will not be taking into consideration. Likewise, I1, I2, I3, I have I1 gives I2, I3. So all the different combinations are selected, and we will be taking only the strong rules. This is how the a priori algorithm works. So one of the major drawback of a priori algorithm is we need to have a large database scan. So also the infrequent candidate items can also be included. So in order to improve the efficiency, we have a lot of various approaches like hash-based item set counting, transaction detection, partitioning, sampling, dynamic item set counting. A lot of applications are there. So we are not going to the deep into the a priori algorithm or and its disadvantages, because we are basically going for the implementation of this. So we'll check on that. So before going to the implementation, let's see one more particular algorithm that is used. That is called frequent pattern growth algorithm. This is also a algorithm which is used for rule mining or rule creation, but here we are using it in the form of a tree. So here we need to build tree structures, and from this tree structures we will be finding the rules. So how do you build a FP tree? So consider that I am having 10 different transactions, and the first transaction, a customer has bought the products A and B. In the second transaction, he has bought B, C, and D. Likewise. So how do you construct a FP tree? First, you have to create a vertex, and what is the particular products associated with that. So from the null vertex, I am creating 2 vertices A and B in the same branch, because A and B comes together. And corresponding to A and B, I am giving a count which shows that how many times A and B have now appeared. So that's about. So now I go to the second transaction, it is B, C, and D. I'm checking whether I'm having a vertex B directly linked to null. No, I don't have a B directly linked to null. I have a B which is linked through A. I need a B which is directly linked. So I don't have, so I need to create another branch. So I am creating another branch B, C, D. Again, I am giving the count. B is equal to 1, C equal to 1, and D equal to 1. Now again, I need to read this particular transaction again and again. And finally, after completing the 10th transaction, I'll be getting a FP tree like this, shown in the figure 4. So now you can see that what is the basic count of each items. It is also represented over there. So I can directly find out, okay, which items are more frequent and which all items actually frequent with along with these combinations. For that, we will be finding something called conditional pattern base. For example, I need to find a particular rule on generating on E. E is a product, right? So what should I do? I need to build a pattern base for E, which means that all the branches that ends in E will be taken into consideration, and we will be taking, so which all items end in E, which all item end in DE, which all item end in CDE, which all item end in BCDE, which all item ends in ABCD, and likewise you will be getting almost all the trees that is needed, and finally you can come up with a particular path where all the frequent items are extracted, and you can finally come up with a rule saying that okay, after a particular transaction or after a particular item, I was able to find out that the transactions containing C, D, and E was repeating, say, n number of times. This is the same process that we have done on the other algorithm also, but here we are using an FP tree in order to find the transaction. So this is how a FP growth algorithm basically works. And now we have done with E, right? Similarly, you have to do for D, C, B, and A. So whatever be the final item set you are taking, you have to check out for all the other items that is being related to that. So this is how we will be finding the item sets in FP tree. So FP trees does also have some disadvantages. So for each item set, you have to find the conditional pattern, you have to find the full FP tree, and most of the system, there might be issues with the memory. So it might not be easy for the FP tree to fit in the memory. For very critical application, like say a rule generating in a power plant. So whenever the oil goes on a particular temperature, the system need to recycle the water. So in such cases, if the memory gets flooded, what happens? The system actually crashes, saying that, okay, fine, the system was out of memory, so I couldn't give you an alert. So that actually pushes you to a catastrophe. So EasyLat is another method. So EasyLat is another method where we actually work for the vertical data set. So till now we were using horizontal data set. That is in the first item, in the first transaction, I bought A, B, and C. In vertical, I'm telling that A, the product A was taken in the transaction 1, 4, 5, 6, 7, and 8. So where exactly EasyLat comes and where exactly a priori algorithm comes? A priori algorithm comes where the number of people coming in the shop are high. If you have a supermarket, you will be using the a priori algorithm. But if you are having a small tea shop where the number of items are small, okay, items in a tea shop, how many items will be there? There will be tea, coffee, and say some snacks. But in a supermarket, how many items are there? It will be from say almost all the household activity or household appliances and the products that you need. So whenever you have more products, you will be using a priori algorithm, and whenever you are having lesser number of products, you will be using EasyLat algorithm. So EasyLat also work in the similar method. You will be taking each and every transaction. You'll be finding an intersection of or a union of this intersection of this transaction, and finally coming up with a transaction ID table. So here I am having a particular a horizontal database. First thing is you have to change it into a vertical format. From the vertical format, you have to find a depth. You have to traverse a depth first traversal from left to right, which means that I am looking for transaction which is in common to A and B, C, D, and E. From that, I will be again splitting into a particular transaction having DA common with C, D, and E, and DABC common with D. So similarly, all other transactions will be found out, and you will be finally getting which all item sets comes in together. Okay, so this is the way by which we'll be using EasyLat algorithm. So EasyLat is also a particular scheme by which you actually find out the various rules. So we have seen a priori algorithm, FP growth algorithm, and EasyLat algorithm. Now we can move to another algorithm called Tertius algorithm. This is a normally used in AI gameplay. So whenever you are having a AI system, for such AI rule minings, we'll be using Tertius algorithm. It's a top-down rule discovery system based on first-order logic. The rule actually is an empty rule to begin with, and whenever a particular rule is getting, we will be adding into that system. So finally, when all the item sets are being visited, we will be coming up with a particular rule or generating a conclusion saying that if we do so and so, this is the particular effect. So one of the basic example you can see, consider that I am checking out for the various attributes for a tennis match to happen. These are the various attributes, say humidity, outlook, and temperature. Using these three attributes, I am going to predict whether the play or whether the match will happen or not. So I am checking whether the humidity is normal, overcast, and the temperature is 35. Yes, fine, that match will happen. What happens if the humidity is too high? If the humidity is too high and if it is sunny, you can see that on both cases, the play was not happening. So by actually checking the various conditions, I can actually come up to a conclusion saying that whether a game playing will work or not. So that's how a Tertius algorithm works. So these are about the various algorithms which I wanted to show you or give you a brief intro on. So now let's see how these algorithms are basically implemented. All these algorithms, you can also have a hands-on on the particular session. I am going to introduce you to a software, an open source machine learning toolkit, which is called Weka. So give me a minute. So coming to Weka software. So Weka is one of the open source toolkit that is basically used by almost all the um, I can say amateur machine learning experts in order to compare the system that they have actually built against something which is very much relevant. Okay, so how the from where the Weka software came, what is the basic background? Let's see on that. Okay, so Weka is actually a bird that is native to New Zealand, which is a flightless bird. So okay, it's a flightless bird seen in New Zealand. So from where this particular software came. So Weka actually stands for Waikato Environment for Knowledge Analysis, all rule-based generations. It actually is a software which have a large collection of machine learning algorithms and data processing tools, which is basically implemented in Java. So now it is not, we cannot say that it is implemented only in Java. There are variations available, but most of the algorithms are basically built in Java. So if you want to have a complete look on each and every aspect of Weka, you can check out the particular book written by Ian Witter and Eve Frank on data mining. You can see about the Weka. Almost all the applications have been explained in this book. Okay, so let's see a basic introduction on this particular software. Veka is actually a collection of machine learning toolkits, but one of the major advantages, every day you will be having some updates. It's an open source toolkit. Yes, today I started working with a priori. Finally, after doing some analysis, I came to a conclusion like, what if I can build a new algorithm which incorporates a particular idea? You can actually get the source code of that particular algorithm, priori algorithm, do the modification and try out with your data set. If you find that that particular algorithm actually works, you can directly go to the Veka forum that is available. You can post your code saying that I have done a modification of the algorithm and I got a particular result and it seemed to be more promising, which means that you are now a contributor of the particular software. So whenever you find like you need to have a particular software or a contribution, you can directly do that. That's a major use of having an open source software. So this particular Veka is having, okay, not three, okay, three graphical user interfaces and one command line interface. So there are a lot of pre-processing tools, classification algorithms, regression algorithms, association algorithms are available. This Veka was actually a funded project by the New Zealand government, and from that funded project, they actually developed a particular software, and even now the development is going on by adding a lot of new features. So this is the basic timeline from starting from late 1992 and till even now they are actually working on a product called MILK, which is for I will tell about that. That is actually used for bio health informatics. So back then, this was how the Veka software looked like, and there were a lot of version. They are now in a developer version of 3.7.8 and a stable version 3.6.9. Even a stable version of 3.8 is available, but some of the features are not available over there. So now it's actually a platform or a package manager. So anyone can create a new algorithm, give to the forum. They just do the validation. If it finds great, they will be uploading it to their servers. So now this is the current version of Veka. So this is how the Veka software looks now. So we can move to each and every function. Okay. So one of the major thing that we need to check is how is the data formatted or how is the data used in Veka. We told that these particular algorithms all are checking out or they are actually working with the data that we provide and give you a final analysis. Okay. So Veka actually works in the data format .arff. Okay. So if you can, it's not necessary that you write your data on ARFF format itself. You can actually write using CSV also. So in every computer, I know that you will be having a CSV file. Excel file, save as, comma separated, delimiter CSV. That particular CSV will also be taken as an input to the Veka. You can also give data directly from an URL or an SQL database using JDBC. I tool is basically supporting Java. That's why we are using the JDBC connectivity. So this is how a ARFF file format looks like. You will be having the attributes and you will be having the data. If you see the first second line at attribute age numeric, which means that I am going to provide a lot of data, and when the data is starting, the first attribute will be age and the data type will be numeric. So check the second paragraph at data 63. That is the age. And what is the second attribute? Second attribute says whether you are a male or a female. So that is on the data second part. Third attribute is the type of chest pain. So that is, it can be either of the three: angina, asymptomatic, agenal, or A-type agenal. So four more. So any four can be the second one. The next one is cholesterol. That is a numeric. So for our next attribute will be a cholesterol. You can see 233. you need to know whether it's an exercise induced angina, and if it's yes or no, and whether it is present or not. So you have to first define the schema. Okay, this is similar to the schema that you use in data warehouse or in XML. First you define the schema that goes in the attribute part, and then you will be writing the data. So this is how you write the ARFF file format. So whenever you start Weka, this is the initial window that you will be seeing. You will be having 4 different options. You can go for Explorer tab, Experimental tab, Knowledge Flow, and a simple command line. So it is basically have the first 3 are the graphical user interface, and the last one is a command line. So today we will be basically discussing with the graphical user interface and how you can pull a data into it and finally work on the particular data. So I told that we are not looking much to the command line. We will be starting with the Explorer tab. So whenever you go to the Explorer tab, you can see that it is basically used for pre-processing of data. So data will be normally imported from ARFF or CSV or binary or from a URL or from using JDBC, etc. From whatever ways you import a particular data, you have to make sure that the data that you have just imported is actually don't have any noises or missing data, or if you have such lags or any jitters, you need to remove them. Only if you remove the jitters and noises, you will be getting a root which is actually a valid one. So consider a situation like I am giving a particular survey to 10 students. Okay, I am giving a survey question to 10 students. What if they have actually filled first 2 or first 3 options, they will be filling it correctly. All the others, they will be just randomly ticking yes, no, yes, no. What happens if such a particular survey result is taken for analysis? You will be getting a false result or a false analytics. So such sort of things need to be removed. That's why pre-processing is very much important. So whenever you go to the pre-processing tab, you can see that there are a lot of options available. So first, in order to pre-process, first you need to select a data set. So whenever you install Weka, there will be some inbuilt data set coming that will also be there in the data folder. So you can open. So here I am taking a iris data set, which actually tells you what the particular flower, to which class the particular flower is belonging to. We have taken some attributes like sepal length, width, petal length, and petal width. So you are going to have the classifications using the four different attributes: sepal length, sepal width, petal length, and petal width. You are classifying the particular flower into iris setosa, iris versicolor, or iris virginica. Okay, so what happens is you can go to visualize all. So now you can see that the particular sepal length, with petal length, width, everything is differently arranged or differently. So now I'm going to select the petal length, choose a filter. I'm having an unsupervised and supervised. Here I'm going to an attribute called discretize. Okay, I'm taking that particular thing. You can see on the right hand side the blue, red, and the light blue colors, right? So if I am going to do this particular discretization function, what happens? I'm going to do the discretization function and use equal frequency. I'm going to make the class into equal frequencies. Click OK. So now you can see what happens to the colors. Okay, apply. You can see that now this particular classes has been equally aligned. So this is an example for pre-processing. Similarly, I will show you the particular software itself. Similarly, there are a lot of pre-processing techniques available. You can take, say, add values to missing values, or fill the missing values, remove noise.
కోడలు ఖుషి ఉందా అని అడిగే వట్టే మా మామయ్య.
anything can be done on that particular thing.
మామయ్యకే ఫస్ట్ చేసిందంట అమ్మాయా. చేస్తే మామయ్య చందన్న వాళ్ళతో మాట్లాడుతుండు కదా, బిజీ వచ్చిందని రాకీ వాళ్ళకి చేసిండు. అర్థమైందా? అది
Now moving to the next
రాకేష్
one,
ఫోన్ చేసిండు,
Explorer tab.
ఫోన్ చేయడు కదా అని నేను చేసి, ఏంది రాకేష్ అంటే
Can the participants please mute your system?
వాళ్ళు ఏమైందని నేను అడిగిన. బుక్ చేసిరంట అదేదో చెప్తున్నాడు అని, ఒక నిమిషం ఆగుతావు బాబీ అని లైన్లో అన్నాడు. అన్నకు చేసి అన్న ఏమనుకుంటుండ, అన్నకే తెలుసా అన్న చెప్తుండు.
Okay, so similarly you can have n number of different pre-processing items, and finally do the pre-processing as such. So coming to the classifiers, so Veka also have a tab for classification algorithms. A lot of classification algorithms are also implemented in Veka. So if you can see the next tab next to pre-process is classify. So you can choose the classifier. Say you can see you have bias, you have decision trees, you can have random forest, you have say k-means, you have multi-layer perceptron, neural network. Everything is actually already implemented on this particular machine learning tool set. So consider that you are having a particular data set, you wanted to do a bias classifier on that, and you were trying to implement on Java. Okay, so you have the Java implementation, you did a Java implementation, and you came to see that the particular runtime for the particular algorithm was say 7 minutes. So that is an algorithm which you have created. So now you need to compare with the Java, you need to compare with the Bayes algorithm that is normally used. You can come here, you can take the Bayes algorithm, do a run with your system, and you can check the time. So if you see that the Bayes algorithm which you have developed is giving a better time complexity, you can just have a very good statistic saying that you have a modified version of Bayes algorithm, right? So from the tab you can select any classifier. Now here I am selecting J48. From J48 I can you have a lot of options available. You can use the testing data, you can fix the number of cross validations. What is cross validation? The number of folds that you need to do for a testing, right? You can fix the percentage split, etc. So here I am doing the percentage split to be 66, and I am going to fix it and going to start. So when I start, you will be getting a result like this on the classifier output. So if you want to see the classifier down, you can see the confusion matrix is also there. So these are the items that, so whenever you are working with a research paper, so what are the things that you basically want? You will be basically checking for the graphical representation, the confusion matrix, the comparisons, the all other sort of items. All these can be very easily got using Veka, which means that you can create a very standard and you can create a very interactive journal paper using this particular software itself. Okay. So from here you can right click and go to visualization, and you can see the tree that is being also developed. Okay, so what have we done here? We have done nothing. We have just given a particular input after pre-processing, and the Veka software, which already had the machine learning toolkit, J48 classification algorithm, did everything for you. You have the results in your hand in say less than 1 minute. So it can be a question whether I'm doing a PhD, I'm doing a classification, is this necessary? No, this is just for using or reassuring your particular results, or to have some classifications. So I'm a particular researcher who works in classification. I will be just trying here over here to check whether this works or not. Yes, if it works, I know that okay, there is a particular particular opportunity for me to work. So only for that we will be using the software. Okay. So you can see the classification error also, right click and go. Also, I'll show you one more example for classification. You can go and select for neural networks. Yeah, select the neural networks, and you can directly go to start. You are getting the neural network. Number of hidden layers, number of output layers, everything you can actually fix it. Okay, I will show you how we done it in the basic work also. You can give. So after classification, we are coming to something called clustering. Similarly to classification, there are a lot of clustering algorithms which are basically implemented. So we have expectation maximization, simple k-means, cobweb, x-means, farthest first. So this is actually, I haven't updated the Veka in a long time. So there are now a lot of classification algorithm which has become an add-on system. So that's why I was telling. So if you are working on a particular algorithm and if you have a particular thing, you can directly post on the Veka forum and they will actually validate it. And if they find it good, they actually adds on the next add-on or the update version. Okay, so you can directly go to the clustering. I'm selecting cobweb. So I'm finding the classes to class evaluate and starting. So you can see that the item has been classified. So you can see the number of instances where it has been incorrectly classified, that is 33.5. You can see the confusion matrix. So only thing that you need to know is you have to make sure that how cobweb algorithm works. Only if you know how the cobweb algorithm works, you will be able to analyze the result that you have got. Okay, so that's how you do the cobweb algorithm. Coming to here also, you can see the tree shaped algorithms and you can look for the cluster assignments. So from the clustering, you are coming to something called association. Association, we have already told about the a priori algorithms, etc. You can take a particular data set, go to associate, check for the a priori, and you will be getting different options. So here you can see that say single size transaction L1 is 20, which means that single item sets with frequency, bread, cereals, that is 20. L2 means bread and cereal together. So 3 means bread, cereal, and milk. 4 means bread, cereal, bread, juice, and milk. So likewise. So and the different options are also given. Say what all the things have been gone side by side, or what other rules being generated. So that can also be included in the associations. Then we have the visualization tab. So what all things that you have done so far can be whenever it comes to a research paper or whenever it comes to a representation, writing a report or technical article or a thesis, what actually means a lot is how you represent the data, how you present the reports. So we have in Veka, we have the data visualization tab, which actually gives you almost all kinds of information that you need to project, whether it be in case of error detection or whether it be in the case of noise or the way by which the classification is done, the exact color, the class classification, everything can be got using the data visualization tab. So you can go to the visualize option over there. You can select what type metrics can be. You can select the plot size, the point size. Likewise, you can get almost things. So these are all the jitters that you'll be having. You can select any one. It can be maximized. So these things can be actually exported as a JPG image or a PNG image. Or you can, these sort of images that you get from MATLAB also can be used. So directly, so if you have an output from a MATLAB saying a particular function, saying a particular graph, okay, I got a particular graph from a MATLAB. How can you simulate that thing in Veka or in a machine learning system? You can directly give that MATLAB processed image to a JDBC, install a JDBC, start a JDBC connection, take the data from there, and the system will simulate you the basic axes, x-axis, y-axis, and the function. So that's very easy over here. So you can actually select that particular portion of the graph. It will be enlarged. So almost all the things have been classified in that particular tab. Coming to the experimenter tab. So once you are done with the Explorer tab, you have another tab called Experimenter. This actually makes it easy to compare the performance of different learning schemes. We have told why we will be using Vega. So this is why we are using. It can be from, say, classification problems to regression problems to write a result to a database or from a database. Anything can be done in the using the experimenter tab. So whenever you select an experimenter tab, there will be 3 options for setting up and running and analyze. So first you have to take for the JDBC connectivity or the database or the file name or the link that you have. After taking the connectivity, you have to check for the connections and give the particular data set. Here you can see that I have given the iris data set as a ARFF format, vote data set and a class data set. And here I am using a JDBC connectivity in order to do the experimentation, and a 10-fold cross validation is also being performed here. So here I am going to have a look on J48 Navy Bayes algorithm and a neural network. You can just run, you can start, there are no errors. When you analyze that, you can see that what is the experimental process. Okay, you will be getting the particular items, and finally you will be getting the data on a particular tree like this. So it can be JS48, neural network, or Navy Bayes. Okay. So that's how we run the experimenter setup. So coming to the knowledge flow, that is a third GUI used in Vega. So this GUI basically, what does this GUI does? So like till now we have told like either we can do classification or we can do a clustering or experimentation. Consider that I am doing a particular big project. In a big project, what I am going to do is I am taking some data. I am going to pre-process it. From the pre-processed data, I am doing a classification. From the classified data, I need to do some sort of clustering. And from the cluster data, I need to get the data and do a sort of association and finally come up with a rule. So is such a long process available in Vega? Yes, that we can do in the knowledge flow environment. So in almost all the tabs that we have shown till now, it was just like give an input, perform a classification, you get an output. Okay, now from here on, you can actually control the flow by which the data is going. So this is the flow diagram, knowledge flow work. You can select the data source. So from the sensor, I'm taking ARFF, and you can take a data visualization. That is in order to see the data. You can just, everything is a drag and drop. Okay, click on there, click on the flow area. So you can get a data set, and the data set will be given to the data visualizer. And you can continue like this. So what happens here? I have a data set, 2 data set, either data set. It is given to a data visualization and summarization. I'm giving that to a scatter plot matrix for a cross-fold validation. I'm selecting an attribute from there, giving that test and training data into SMO, and finally giving a performance evaluator, and finally seeing the result as a text viewer. So this is a sample thing. So likewise, you can create your own method. You can create your own method and find out how you can do some sort of processing. So by this way, you can kindly take into the various options that is available in Vega. You can configure, you can start loading, show results, and that will be giving the final results. So in the what is the difference? In the earlier case, you gave the input, you run the system, you got a particular output, you are happy. But here you can do what all type of application or what all sort of increases that can be available. So that's about the 4th GUI also. So we can say that this all has been changed. Now there are 20 around people working in the Vega project now. So I have told that there are a lot of projects based on Vega that is coming. So AIL is a very upcoming system which is actually doing large scale machine learning experiment. And we also had something called MILK, that is what I told, multi-instant learning kit for bioinformatic kind of learning. And we have MOA, Massive Online Analysis. That's a framework that supports data from data streams. That is for satellite data, say, or the real-time data that you get. So Veka is on a very large platform, which actually gives a researcher a very full offhand idea on how we can do all these things. Okay. So one of the major thing about the particular software is that whenever you have a particular modification or enhancement, you can go directly to the online, select the Veka forum, get in touch with the developers, and you are done. So that is the sort of opportunities that we have having in the particular system. So you can just go to the particular link, okay, www.cs.waikato.ac.newzealand/ml/Veka. You can also go for Google and search Veka download. You will be getting the particular software and a lot of projects based on this. Okay. So that's about the particular Veka. I will quickly show you how the process actually works. Okay, so I will share the desktop. I guess it's visible. So this is the hands-on of the Veka system. Okay, so this is the environment that we were telling. Okay, so we have in the updated version, we have a workbench also, which is similar to a knowledge flow. So first we can go to the Explorer tab. Okay, so here we told that you can see, go to the open file. You can have the Veka files over here, and the data is here. Lot of data, ARF of data are here. So let me see. We were dealing with the iris data set, right? So I'm taking the iris data set and I'm putting it, so you can see here. So I will also show you how this particular data set looks like. Veka files, data, iris data. You can open with TextPad or something. Okay, text edit. So you can see that this is what we were dealing with. This is the ARF format. Okay, you have the attributes written over here. Then you have the data. Okay, so this is how the data set actually looks like, and this is a pretty long data set. And from this data set only, we are moving to the particular Veka. So this data set has been fed into here. You can choose the various filters that is available. You can go for, say, a supervised filters or an unsupervised filter. You can discretize over here. So any function can be done over here. You can have, say, where is that? Yeah, you have the kernel filters over here. Normalization, principal components you can select, reorder, so replace with missing value. Any possible pre-processing technique can be done using this particular thing. So then we are having the classification. So we have selected which one? We are now selecting the, okay, now we are going to the classification algorithm. So let's take a tree based, so that we will be able to understand better the J48 algorithm. I'm just starting the algorithm, and in a click of a second I got the result. You can right click on here, J48. It will give you, you can have an option called visualize trees. If you give the visualization tree, this will be the tree view that you'll be having. It can be auto fit to screen, auto scale. You can directly download it. Anything can be done. Okay, so that's about the classification. You also have the neural networks available. I will show you that also. It was on. Yeah, functions, multi-layer perceptron. Okay, so we have the multi-layer perceptron. So if you double click here, you will be getting a particular window. Here you need to put the GUI as false. So we need to put it as true in order to see the GUI, and I'm giving as okay. Now I'm going to start the system. So now you will be getting the GUI also. You can know well better. You can give the number of epochs. Learning rate can be given over here. Start and accept. Okay. So in this way you can do this particular. Okay, we also have clustering available. You have a lot of clustering algorithms like say earlier we told like right, there was only 2 or 3. So now we have the filtered clustered hierarchical cluster, simple k-means. You can select anything and do the co-web out. So you can do say the model accuracies. So what is actually happening here? We have the entire system running here. You can directly have if you are a machine learning, make sure you can directly get to the code, do a lot of hands-on, and finally get what we are doing. Similarly, we are having logs. So here finished. Okay, fine, clear. Here we can use. Okay, here we need to select the right. I'll go. So from the open file data, I'm taking a supermarket data set. Yeah, we have a supermarket data set. So I will show you how the supermarket data set looks like. So a supermarket data set, if we open on a text editor, so see, these are the attributes. So what are items? T is a true or false? Tea, canned food, breakfast food, items, spices, medicines, hair care. So all these are the things that are in the supermarket. So all these are attributes. So it's a bigger data set. And from here we are starting the data. Okay, the question mark means we don't have the data. And if T means we are having the data. True, true, or the data. So likewise, we can arrange for the data here. Okay. So this is the data that we have selected here, and go to the associate. Here we am having, say now I'm having 3 options: a priori algorithm, FP growth algorithm, or filtered a priori. You can start with a priori and go to start. You can see that the the bird is flickering, which means that it was running. So these are the rules that you have created. Okay, which means that when biscuits equal to true and frozen fruits equal to true and fruits equal to true, which means that people buying a lot of these things will has a chance of buying bread and cake. So in 788 transactions, 723 have bought bread and cake also. So such sort of rules can be generated using the associations. You have the select attributes. This is in order to select or evaluate the attributes in a particular search method. Or if I'm having a particular 2 attributes saying A and B, I can rank the particular attribute saying for a particular operation, which one is better. So for that, we can use a ranking. So we can have the visualization. So if you had any errors or something, you can see over here. You can see the jitters also here. So you can click and see a particular tab. So what is the particular data set over here? What is the noise? Where exactly the on x-axis these items lay? So such sort of things can be seen in this particular tab. So these are the items that is basically working on Explorer tab. Coming to the experimenter tab, we told like where we need to have a JDBC connectivity. So right now I have not installed Java here, so I'm not able to show you the JDBC connectivity. Else, like I have shown in the presentation, you can try out for the JDBC connectivity, try out for some Navier or J46 or neural network, try out with some iris dataset or GLASS dataset. You can see how this particular experimenter tab works. This is one of the major items of Weka, and this is the highlight of the Weka, which is the knowledge flow background. This knowledge flow background actually gives you a particular idea, or gives you a particular way by which you can actually do almost all the processing. On the left hand side, you can see the ARFF loader. Click over here and click on the link. You can directly get the ARFF loader over here. And from the ARFF loader, you need to find, say, I'm going to associate, I'm going to do a priori algorithm. do an a priori algorithm. And finally, I need to see the results. Okay, so visualization, I am taking a text viewer, I'm giving a text view. So now I need to make connections between these algorithms. So I'm configuring it. Okay, this is correct. So I need to put the data set to a priori algorithm, and from the data set, I will be getting a text that is given to a text viewer. And what I need to do, I need to load the data. So I'm going to go for the data set. I need to file name, Veka data set. So it's a supermarket data set that I'm trying to select. So that is selected. I'm being OK. And they can go for the copy, and you can start the process. So once you have done the process, you'll be getting the final result over here, show results. Okay, so you can finally see. So this is for just, so consider that I'm having a loader that need to be given to a priori, and the particular result that you are given, you have to classify that result. You can go to the left hand side, you can select a classifier. Okay, I'm going a GD SGD classifier. You can directly have a association to a SGD, and from there, if you need to find a expectation maximization, you can do that. You can connect these two things. You can have the batch size of 100 and make sure that this is, and don't replace missing is a true. Okay, so you can actually work around with each and every option that is available. So what exactly, or where exactly Veka comes into play is, it actually helps an user to play around with the system and make sure that he is able to find out the final results. Okay, consider that I'm a Java, I'm a research scholar, and I'm working on this data analytics. I'm working on Java. Day and night I'm coding on Java, and finally comes up with a solution saying that my code was not working. So that actually is a trauma to a researcher. So what we can do, you can actually put your hands, burn your fingers, come here, learn how to do the processing in a already implemented platform. Check whether you can do like this. What happens if you do like this? What are the expected results? So once you have a baseline, then you can find out, you can go by yourself, you can code, you can find out the explanations and finally come up with this. Okay, so that's where exactly the Veka comes into play. Okay, so that's about a Java platform also. So that's what I wanted to convey through this particular session. So, so we had started by seeing some of the basic algorithms. We have seen how they are working on Veka, and we have also seen like how the basic algorithm also works. So I think we can have a small discussion on the things that we have seen, and finally wrap up the session. So I will be happy to help if anyone has having any queries or something. So I'm open for any queries or questions. Over to you guys. So it seems like everything is clear or nothing is clear. Just go to Google, try out for Veka. You can get a lot of materials of Veka itself. You can just download it and get it. Okay, so I hope if there are no queries, I think we can wrap up the session. Is the host with us? think we are not audible, madam. Yeah, sure, sure, sure. So if you have any queries, just get to the post. They will share my contacts. So if you have anything, you can directly mail me. I'll be happy to help you. Anyway, thanks a lot for the coordinators for inviting me for this particular session, and thank you participants for all the patience that you have had during the entire session. Thank you. Stay safe and have a great time. Thank you. Thanks a lot. Bye.
Good afternoon, ma'am. Are you able to hear me?
Yes, ma'am.
Okay, what about my PPT? How can I share? You have to give me permission to share my PPT, or shall I send it to you? Ma'am, are you able to hear me?
Ma'am, shall we start?
Yeah, we can start, but I want to share my presentation, no? So
One
I
second.
want, yeah, I want to share my PPT. Okay, okay. So is my screen visible?
Yeah, ma'am. Shall we start the introduction?
Yeah, we can start. Yeah, we can start. Shall I start with the presentation?
One second, ma'am.
Yeah.
A very good afternoon to everyone. I'm glad to introduce our guest, Dr. Dhanalakshmi Professor, who has completed her BE Computer Science MBA, completed her MTech of Computer Applications, IIT Delhi under QIP, and completed her PhD in Computer Science Engineering. She has 22 years of teaching experience and 17 years of research experience, and her current area of research is under machine learning and speech processing. She has published two papers in the Elsevier Journal during 2009 to 2010 under Professor P.V. Vaidyanathan Endowment Scheme, former Vice Chancellor. She also received Best Paper Award in the Interconference on Indigenous Management Practices 2009. Now I request Dr. Dhanlakshmi to address the gathering. Please, ma'am.
So good afternoon, participants. I think there was a little bit delay in starting my presentation, but anyway, I'll try to compensate for the lagging um, period. Okay. So are you able to see my presentation? Is it getting shared? Okay, assuming that all of you are able to visualize this presentation, I will start with it. So now two important topics, two important clustering algorithms we are going to discuss in this webinar, whatever it is. It's K-means clustering algorithm and expectation maximization algorithm. These are two clustering algorithms which are widely used in machine learning. Okay, so first, we will start with this K-means clustering algorithm. This algorithm is mainly used for as an unsupervised learning algorithm, and it is also used in many other cases. Like, for example, it is used in the RBFNN, radial basis function neural networks. EM algorithm is used for Gaussian mixer models. Okay, so we'll see both these algorithms in detail with an example also I've given. So clustering, it is an unsupervised learning algorithm, and in supervised learning algorithm, learning is based on training data. In unsupervised learning, learning is done without training data. So in supervised learning, we know the category to which the test data which the training data belongs to. Whereas in unsupervised learning, we don't know the category to which the training data belongs to. So this K-means clustering algorithm is an unsupervised learning algorithm. Okay. So I've given you an example. So to visualize, this seems a little bit simpler, but in practical terms, when you want to visualize this data, when it is more than two-dimensional data, you will not be able to visualize it exactly. So in that case, you cannot visualize it. But here, so this is just for making it more simpler. I have made it like this. There are 4 clusters. By looking at it, you can say there are 4 clusters. In k-means clustering algorithm, we don't know the category to which the test data belongs to, but we have a prior knowledge on how many clusters are available in this data set. Okay. We have a prior knowledge on how many clusters are available in this data set. So this is an example of 2 clusters. See here, I've given you, this is height is 1 dimension, weight is the other dimension. We'll just take for an example, we are considering a 2-dimensional data. All of you must be familiar with what is 2-dimensional data. There are 2 dimensions. One is the x-axis and another is the y-axis. If it is more than 2 dimensions, then it is a little bit difficult to visualize the data. So I've given you an example of a 2-dimensional data. So looking at this, you can say there are 2 clusters, C1 and C2. Okay, C1 is the center point, centroid of the first cluster. C2 is the centroid of the second cluster. So if a test data comes, you have to find out the distance from this test data to the centroid of the first cluster and the distance from the test data to the centroid of the second cluster. The minimum distance will give you the category to which the test data belongs to. This is just a small explanation. Now, see here, where do we go for this clustering algorithms? When you have a particular category of data and you want to form clusters within that category, we go for k-means clustering algorithm. See here in this example, in this figure, there are 4 clusters belonging to red group and there are 4 clusters belonging to the blue group. See here, C1, C2, C3, C4 belongs to group 1 and C5, C6, C7, C8 belongs to group 2. Now, suppose you want to find out the category to which the test data belongs to, you have to find out the distance from the test data to C1, the distance from test data. You can use any distance measure, the test data to C2, the test data to C3 and to C4. So you get 4 distance measures. Among these, which is the minimum value, you have to find out. Then the distance from the test data to all other clusters C5, C6, C7 and C8, and you get a minimum value. So for this, you have a minimum value. For this, you have a minimum value. Find out the minimum of x comma y, and that is the category to which the test data. Suppose the minimum value is C1. You can say this test data belongs to group 1. If it is C6, you can say it belongs to group 2. So in this, you have only 2 groups, 2 major groups, but each group is again clustered into 4 clusters. I hope you understand. Okay. So that is, there are 2 groups in this. Each group is clustered into 4 clusters. And if you want to find the category to which the test data belongs to, find out the minimum distance for each cluster. And out of this, the minimum distance to which the test data belongs to will be categorized by the minimum value, right? So unsupervised learning problem deals with finding a structure in a collection of unlabeled data. So what is this clustering? The process of organizing objects into groups whose members are similar in some way or the other. So a cluster is therefore a collection of objects which are similar between them and are dissimilar to the objects belonging to other clusters. So I've used the term similar. The term similarity varies from application to application. So a cluster is therefore a collection of objects which are similar between them. That means those objects which are belonging to a single cluster will be having minimum distance between them, whereas they are dissimilar to the objects belonging to the other clusters. Okay, so what is the objective of clustering? Objective of clustering is nothing but organizing the data into classes such that there is a high intra-class similarity, that is intra-classes within the class, okay, and a low inter-class similarity, that is the objects belonging to different classes, say class 1 and class 2 should not be similar. That is low inter-class similarity. So finding the class labels and the number of classes directly from the data, this is in contrast to classification, and more informally finding a natural grouping among the objects. Okay. So what is similarity? So looking at this figure, you can say we have 4 objects. So when I ask somebody, what are the two similar objects here? One of you can say this, and A and B are similar in shape or size. So A and C are, the other person can say A and C are similar in color. So the other person can say C and D are similar in shape again. Okay. This is a little bit bigger in size when compared to this. So it depends upon the perception. So depending upon the application, the similarity varies. But anyway, star A and B, A, B and C has the same size. Star A, C and D has the same color. Size and color are examples of features that can be measured. Okay. So normally similarity is quite difficult to measure, and it is a quantity that reflects the strength of relationship between two objects or two features. Okay. So what is the significance of measuring this similarity? What is the significance of measuring this similarity? So we can distinguish one object from another, and we can group them based on the similarity or dissimilarity. Once we group the objects into groups, we can understand the characteristics of each group, and we can explain the behavior of the clusters. We can classify the object into a new object into a group. That is testing you can do object. We can also simplify the data that we have into more reasonable relationships. These are the significance of measuring similarity. So coming to this k-means clustering algorithm, the objective of this algorithm is to cluster the feature vectors, and this k-means clustering algorithm organizes the feature vectors into k number of groups. K number of groups we can design. Okay, so when you want to perform training, you can just try it with a number of varying k. So you can vary k from 4 to 8, 12. You can see the performance, and when the performance is optimal, you can stop there. Okay. So just to study the performance of the training algorithms, you can vary k and find out how the performance varies. In certain algorithms, the performance of the algorithm will keep rising and to a certain level, and then it will start decreasing. In that case, you can stop with that k. So grouping is done by minimizing the Euclidean distance between feature vector and the corresponding cluster centroid. This I will explain with the help of a numerical example. And you call this k-means clustering algorithm is a hard assignment. That is because either the feature vector, or you can say the objects, right? So you are extracting the features from the objects, and you're going to classify the feature vectors as belonging to this category or the other. You call it as a hard assignment. That is because for each iteration, you assign the object to either this group or to the other. Okay, you assign this feature vector to this group or to the other. That is why you call it as the hard assignment. Whereas in the case of EM algorithm, it is a soft assignment. That is, you have a probability of assignment of the data to this group and to the other group. Whereas here, for each iteration, suppose the data item is belonging to group 1, it is only belonging to group 1. Whereas in expectation maximization algorithm, you call it as a soft assignment. Say 75% of the data item will belong to group 1, 25% to group 2. So you call it as a soft assignment in the case of EM algorithm. But anyway, you can make use of both these clustering algorithms in machine learning algorithms like Gaussian mixer models or radial basis function neural networks. Okay. So here, see, what is this algorithm? Initialize k centroids, compute the distance between each feature vector to the centroids, assign the feature vector to the centroid whose distance is minimum, re-estimate the centroids, and you have to repeat the steps until there is no change in centroids, or if there is a change in centroids, like for example, if group changes occur for every iteration, for n number of iterations, you stop it there itself. So this is the stopping criterion. So somewhere you have to stop, right? You cannot keep on changing the groups. So it can be for n number of iterations. So you just fix it for a certain number of iterations, and there you get the result. Okay. So first you initialize the centroids, k centroids. Suppose if it is four groups, you initialize 4 centroids. Initialization, you can just assume, or you can take one data point itself as one centroid, compute the distance between each feature vector to the centroids, and assign the feature vector to the centroid whose distance is minimum, re-estimate the centroids, and repeat the above 3 steps until there is no change in the centroids or for a fixed number of iterations. So this is so simple. See here. So you refer to this flow chart. Initialize k centroids. Okay, this is what I said. Compute the distance matrix. Then you assign the feature vectors to the center point based on minimum Euclidean distance. There are a number of distance measures like Manhattan distance, simple matching distance, Euclidean distance. Mostly people follow this Euclidean distance due to its simplicity. Then you can re-estimate the centroids. This can be actually an iterative process where you stop with a fixed number of iterations if there is a group change for every iteration. Okay, so see, listen to this numerical example carefully. See here, there are 4 objects, okay? 4 objects, or you can just imagine these are 4 data points. And these are the features extracted from those objects. It means what? This is one dimension, this is the other dimension of this object, okay? There are 2 dimensions or 2 features extracted from this object, medicine A. So from this object, there are 2 features extracted. It can be a person, and this can be height, this can be weight. Okay, this depends. So for simplicity, we have just taken a very small example where there are 4 objects and 2 features extracted for each object. See here, 1, 1, 2, 1, 4, 3, 5, 4. So these are the features which are extracted from these 4 data items. So what are the different distance measures? You can just Google and see. There are so many distance measures. Normally you use Euclidean distance measure, and people sometimes they use this Hamming distance or simple matching distance, whereas in the case of agglomerative clustering, people use this Manhattan distance. Okay, so in literature, if you see for k-means clustering algorithm, the most simplest distance measure used is the Euclidean distance. There are other distance measures also available: Hamming distance, simple matching distance, Jacquard's distance. And for categorical, if it is binary variables, you use these distances. And if they are categorical variables, you use Kendall distance. And if it is quantitative variables, you go for Euclidean distance and city block distance. Okay. So what is this Euclidean distance? As we all know, if there are 2 data points, X and Y, that is 2 n-dimensional data points. Okay, you just consider there are 2 n-dimensional data points, X and Y, where X is equal to X1, X2, etc. up to Xn. That means what? We are extracting n features from this data point. Okay, it can be an image also. So these are 2 n-dimensional data points. How do you call this as an L2 norm? The Euclidean distance between X and Y is denoted by L2 norm. That is, the distance between X and Y is given by D is equal to square root of the first dimension difference, the whole square, plus second dimension difference, the whole square, plus nth dimension difference, the whole square, and then the square root. Okay. This you must have studied earlier in college or your school days itself. But anyway, we'll just refresh on the L2 norm. See, the first dimension difference, second dimension difference whole square. You sum up all these and you find out the square root. This will give you the Euclidean distance. I will send you this PPT. You can just go through it afterwards if you want. I hope this is clear. So this is what is called L2 norm. That is the Euclidean distance between any 2 data points. Okay. So see here, this is the plot. There, the data points A, B, C, and D. So our k-means clustering algorithm, in our k-means clustering algorithm, let us assume there are 2 groups. This is just an assumption. There are 2 groups. So we have to assume 2 center points or 2 centroids. See here, first step is initialize the value of the centroids. See, C1 and C2 denotes the coordinates of the centroids. But now here I have assumed data point A itself as the first centroid and B itself as the second centroid. You can assume anywhere else also. You can assume here C1 and here C2. Anyway, the final result will be the same. Okay. So this is centroid C1, this is centroid C2. First, let C1 and C2 denote the coordinate of the centroids. See here, you have to initialize the centroids, because we have a prior knowledge that the data set belong data set we have consists of two groups. Okay, since it is an unsupervised learning algorithm, we don't know the category to which the training data belongs to. Whereas if it is a supervised learning algorithm like support vector machines or backpropagation training algorithm, we know the category to which the test data belongs to. This is just, we have a cluster, a group of data. We have to cluster them based upon the prior knowledge. So now we have a prior knowledge that this data set consists of two groups. Okay. So there are two groups, so initialize two centroids. If there are three groups, of course, you have to initialize three centroids. This is the first step in this algorithm, right? So follow it carefully. Now we are forming the distance matrix. See here, we have to find out the distance of, see in this slide, the distance of the centroid to A, to B, to C, and to D. So we get 4 distance measures. That is nothing but the values in the first row. This is the distance of A to C1, B to C1, C to C1, and D to C1. Similarly, the second row corresponds to the distance of each object to the second centroid. See here, this is second centroid. That is why you get a 0 here in the second row, right? So column. See here, this is the distance of the first data point to the first centroid. Since we have assumed the first center point and the first data item to be the same, you get a 0 here. That is the distance of A to A itself. Similarly, for the second group, we have assumed the second data point itself as the second centroid. So here we get 0. That is because the distance of B to B. Okay. The rest you have calculated like this. See, how do you calculate all these? How do you calculate this? See here, we have seen the Euclidean distance given by x1 minus y1 the whole square plus x2 minus y2 the whole square plus etc. up to xn minus yn the whole square. So here we can say 1, comma 1, so square root of 1 minus 1 the whole square plus 1 minus 1 the whole square, that will be 0. And the next distance measure, that is 1. How do you get this? 1 is square root of 2 minus 1 the whole square plus 1 minus 1 the whole square, square root. That will be nothing but 1, and so on. So the first row of the distance matrix corresponds to the distance of each object to the first centroid. The second row corresponds to the distance of each object to the second centroid. I hope this is clear. So the same process will be repeating. So this is the distance matrix, right? This is the distance matrix. So now we have to form the group matrix. So group matrix is nothing but, see in this you have to find out, see what is this to column wise? This is the distance of the first point to the first centroid. This distance of the second point to the first centroid. Sorry, the distance of the first point to the second centroid. So this gives you the minimum distance. The minimum distance tells us the data item is closer to the first centroid or the second centroid. So in this, the minimum item is 0, minimum term is 0. So the first group data item A belongs to the first group. See in the second column, you can say this 0 is minimum. So the second data item belongs to the second group. In this, the minimum value is 2.83. The third data item belongs to the second group. The fourth data item also belongs to the second group. Clear? Okay. So this is the group matrix. See here, A alone belongs to first group and B, C, and D belongs to the second group. This is the group matrix. So this is the first iteration. At the end of the first iteration, we have this grouping like this. See here, the first data item alone belongs to group 1 and all the other data items belongs to group 2. Okay. So the first data item belongs to group 1 and all other data items belongs to group 2. So now first one is distant matrix, second one is group matrix, third one is recalculate the centroids. So how do you recalculate the centroids at the end of iteration 1? See, since we have only one data item belonging to the first group, it itself is the center point, that is 1, 1. For all these 3 data items or objects, how do you find the centroid? you have to just sum up the first coordinate. As we all know, earlier we have studied in school days itself. The center point is nothing but the first coordinate of the first data item, first coordinate of the second data item, plus first coordinate of the third data item divided by 3. 2 plus 4 plus 5 divided by 3. 1 plus 3 plus 4 divided by 3. That will be 11 by 3 and 8 by 3. That is coming somewhere here. So you can see in this figure, C2 is the second centroid. Okay, C1 is the first centroid, C2 is the second centroid. Now this process is over. Now we have recalculated the centroids. Now what should we do? Again, find out the distance matrix. So distance matrix is nothing but object centroids distance. See here, we have found out the distance matrix. That is this first row corresponds to the distance of all objects to the first centroid, distance of all objects to the second centroid. Now we have to see column wise. Among these, the minimum is 0. So first data object belongs to group 1. Among these, the minimum is 1. So the second data object also belongs to group 1. Among these two, the minimum item is 0.47. That is the third data object belongs to group 2. And among these two, the minimum value is 1.89. So the fourth data object also belongs to group 2. So this is at the end of iteration 2. Okay. So again, we have to recalculate the centroids. Say again, now we have two groups in two data items in group 1 and two data items in group 2. Recalculating the centroids, we get C1 is equal to 3 by 2 and 1, and C2 is equal to 9 by 2 and 7 by 2. I hope this is clear. So this is at the end of iteration 2. So this will be repeated for n number of iterations or until there is no group change. So when you repeat this for the next iteration, compute the distance matrix, that is you get this, and then you compute the group matrix, you get this. So previous time also we got the group matrix like this. So now again you got the group. So now suppose you again repeat this for n number of iterations, say 5 number of iterations, there will be no group change. So at the end of the nth iteration, there are two data objects belonging to cluster 1 and these two data objects belongs to cluster 2. See here, this is the final grouping. Okay, so this is just a simple example. So you can just say, looking at this itself, I can say there are two groups, but this is not the case. When your data set is too large, when you have a multi-dimensional data, it becomes very difficult for you to group this. We just have to have a prior knowledge on how many groups are there in this data set, and you can go for a k-means clustering algorithm. So this is our objective, and this is the final grouping. I hope this will be, all of you are clear with this. So I just want to, some of the participants to unmute your audio and tell me, are you okay with this? Can we proceed to expectation maximization algorithm? Am I audible? Okay. So I'm not getting any message from the coordinators, right? So now, okay, then it's fine. I'll proceed to the expectation maximization algorithm. Okay, this is a little bit complicated algorithm, but still, once you understand it, is very easy to follow. See here, expectation maximization algorithm. All of you know about this Bayes theorem. So it finds out maximum likelihood estimates of parameters in probabilistic models. And unlike this k-means clustering algorithm, it is a soft assignment. Yes. Yes. Can I proceed?
Yeah, ma'am. Yeah.
Okay. So EM algorithm finds out maximum likelihood estimates of parameters in probabilistic models. And you call this as a soft assignment. There are two steps again, similar to k-means clustering algorithm, where you will be iterating between the two steps, E step and the M step. Okay. So it is a soft assignment because for every iteration, you don't assign the data set, data item to this group or the other, okay? So E step computes an expectation of the likelihood assuming parameters, and M step computes maximum likelihood estimates of parameters by maximizing the expected likelihood found in the E step. See, actually, when you go for EM algorithm and its notations, it is little bit complicated, but to overcome this complications, I've just given you a numerical example similar to K-means clustering algorithm. So you will be able to follow it in a better manner. See, there are two steps here, expectation step and maximization step. E step is nothing but computes an expectation of the likelihood assuming parameters, and M step computes maximum likelihood estimates of parameters by maximizing the expected likelihood found in the E step, okay? So you all know Bayes' theorem. Posterior probability is equal to likelihood into prior divided by evidence. And that is probability of omega j given x is equal to probability of x given omega j, that is likelihood, into prior probability of omega j divided by evidence is nothing but p of x. So we are, see, in this we are going to compute an expectation of the likelihood assuming the parameters. The next is compute maximum likelihood estimates of parameters by maximizing the expected likelihood found in the E step, right? So see, we start with an assumption. Now, mostly this is used in Gaussian mixture models. Like for fitting Gaussians, you have this expectation maximization algorithm. If you assume a mixture of two Gaussians, again, where do you use this Gaussian mixture models? Especially when you are not able to fit in the data into one Gaussian, in that case you go for a mixture of Gaussian, okay? So for the same thing, you can use K-means clustering algorithm also, where this K-means clustering algorithm is characterized by one parameter, that is the mean vector. But expectation maximization algorithm is characterized by two parameters. One is the mean vector and the covariance matrix. Okay. So what is this? What are these parameters? Yes. See here, theta 1 is equal to mu1 sigma 1 square. And this is the parameters for Gaussian 2. So you know how a Gaussian mixture model looks like. It is a bell-shaped curve, which is characterized by two parameters, that is the mean vector and the covariance matrix. Okay. So the covariance matrix actually tells you the spread of the curve, and mean tells you what is the mean value, right? So there are two parameters, two Gaussian. We assume there are two Gaussians. So the parameters for the Gaussians, theta 1 is equal to mu1 sigma 1 square, and theta 2 is mu2 sigma 2 square. You know how to calculate the sigma 1 square, that is nothing but xi minus mu1 the whole square divided by n. And this is for the second Gaussian, xi minus mu2 the whole square divided by n. Okay. So see now, so we have assumed the parameters. This is the first step, right? Now we have to compute the probability density function for both the Gaussians. Now, if it is a one-dimensional value, if it is a univariate, you can just say probability of xi given theta 1 is equal to 1 by root 2 pi sigma 1 exponential minus 1 by 2 xi minus mu 1 divided by sigma 1 the whole square. So this is probability that the feature vector belongs to the first Gaussian. This is the probability that the feature vector belongs to the second Gaussian. So this is how you compute the probability density function, that is for a univariate. For multivariate, of course, you have it. If you want, even I can give it. But this is for a univariate. We have computed the we have to compute the probability density function for the first Gaussian and the second Gaussian. Theta 1 refers to the first Gaussian. Theta 2 refers to the second Gaussian. So you have to substitute the mean value of the first Gaussian and the sigma value of the first Gaussian here. Here, this is mean value of the second Gaussian and the sigma value of the second Gaussian here. So this is the E step. So you have some more to be continued. E step. So next is compute the normalized probability values. You have coding available in Python for all these, but still you have to understand the principle or the working mechanism of these algorithms, so that just like that you cannot assume how the EM algorithm is used for fitting the Gaussians. So I've given you a detailed step-by-step example. See, now the first step is you have assumed the parameters, then you have computed the probability density function of the feature vector belonging to the two Gaussians. Next, we have to compute the normalized probability values for both the Gaussians. The normalized, see, compute, how do you compute the normalized probability values for both the Gaussians? This is for the first Gaussian, the normalized probability value. This is for the second Gaussian. This is the probability that the first feature vector belongs to the first Gaussian plus divided by the probability that the feature vector belongs to the first Gaussian and the second Gaussian. Similarly, second Gaussian divided by first and the second. This is how you compute the normalized probability values for both the Gaussians. Okay, so this is all expectation step. Now see here again, I repeat, what is E step? Assume parameters, then compute the probability density function, compute the normalized probability values. The next step is M step. M step is nothing but, see here, compute the new mean for both the Gaussians. So we have assumed the parameters, we have then calculated the probability that the feature vectors belongs to the first and the second Gaussian. See, what does our E step say in this? Computes an expectation of the likelihood assuming parameters. So we have assumed the parameters and we have computed the probability density function. Now we have to compute maximum likelihood estimates of parameters by maximizing the expected likelihood found in the E step. By maximizing the expected likelihood found in the E step. Now again we have to recalculate the parameters. See here, compute the new mean for both the Gaussians. We know, see, new mean is equal to sigma I is equal to 1 to n. Only thing is we just give it as xi divided by n. But here, see here, I am multiplying it by the normalized probability value for the first Gaussian. For the second mean calculation, I am multiplying the summation of all values by the normalized probability value for the second Gaussian, right? Okay, so this is how you have to compute the new mean for the Gaussian 1 and Gaussian 2. See, there are a mixture of two Gaussians, both belonging to the same category. So you have to understand the difference between the classification and clustering. See, in classification, suppose there are 5 categories. Okay, we build 5 models similar to how we build 5 support vector machines using SVM modeling. But here, for each group, suppose if it is a male category, there are 2 clusters. For female category, there are 2 clusters. See, there are 2 Gaussians, but both Gaussians belongs to the same group. Okay, so in that case, only you go for Gaussian mixture models. Where do we use these type of application is, suppose we want to classify the height of male alone. See, we can say people belonging to one country will be of average height, male belonging to other country will be short, the other country will be very tall, and so on. So in that case, you cannot fit in the entire data into one Gaussian. In that case, you can go for a Gaussian mixture modeling, right? So EM algorithm, you can just assume EM algorithm is for fitting Gaussians in simple terms, right? So what I've done, now we have to compute the new mean for both the Gaussians. This is the step I'm actually given it stepwise. See here, this is nothing but you just multiply the input values by normalized probability, and then you divide it by n into x. X is nothing but the total normalized probability of Gaussian 1. Ny is nothing but the total normalized probability of Gaussian 2. How do you compute it? You just sum up all the probability values. Okay, so my example will tell you more better. You have to sum up all the probability values, and then you get mu1 is equal to nothing but, see here we computed mu1 divided by nx. Okay, So mu2 is equal to mu2 divided by ny. So here you computed mu2 as xi into yi divided by ny. Ny is nothing but the total normalized probability of Gaussian 2, right? So this is M step. So there are two steps which are going to be iterated, E step and the M step. See here. Now we computed the new mean, and based upon the new mean which is calculated, we are computing the new variance sigma 1 square and sigma 2 square for both the Gaussians. Okay. So I'm telling here variance, if it is more than one dimension, it is covariance. So here sigma 1 square is equal to the normal variance calculation. Sigma I is equal to 1 to n xi minus mu1 the whole square divided by, see here, divided by nx. But here you just multiply it by the normalized probability value of the first Gaussian, normalized probability of the second Gaussian. This nx is nothing but the total normalized probability of Gaussian 1, and ny is the total normalized probability of Gaussian 2. Okay, this is the corresponding normalized probability. This is the total normalized probability. So this algorithm actually iterates between E step and the M step, right? So expectation maximization algorithm iterates between two steps. I repeat, it iterates between two steps, E step and the M step. E step computes an expectation of the likelihood assuming parameters, and M step computes maximum likelihood estimates of parameters by maximizing the expected likelihood found in the E step. See here, this E step is nothing but assume parameters for Gaussians. So we have assumed two Gaussians, theta 1 and theta 2 are the parameters, mu1 and sigma 1 square, that is mean and the variance. If it is more than one dimension, you can go for covariance. So compute the probability density function for both the Gaussians. Then you compute the normalized probability values for both the Gaussians, compute the new mean for both the Gaussians, and then compute the new variance for both the Gaussians. I hope this is clear. So initialization is nothing but assume random values to parameters, and pretending to know the parameter, assign the data point to a component. This is step. And then maximization is fit the parameter to its set of points. Okay, now we see this example. So randomly we have assumed mean, and based upon the randomly assumed mean, we calculate the variance. There are 6 data points. The number of Gaussians is 2. And initial mean is, see, we have assumed 2 mean values. And based upon the assumed mean values, you can calculate the variance. Okay. This is the parameters characterizing the first Gaussian. These are the parameters characterizing the second Gaussian. Okay. Next, see this calculation I've shown here. Now in this E step, we have to compute the maximum likelihood estimates of the parameters belonging to the first Gaussian and the second Gaussian. This is probability that the first feature vector belongs to Gaussian 1, probability that the first feature vector belongs to Gaussian 2. Now xi and yi I've calculated here. That is how you calculate this xi. This is the summed up probabilities. See here. Xi is nothing but probability of xi given theta 1 divided by probability of xi given theta 1 plus probability of xi given theta 2. This is how you sum up these values. So this divided by this plus this will be this value. Okay. So 0.0902 divided by 0.1351 will be 0.6676. You can just do a rough calculation if you want to understand the first thing alone. 0.0902 divided by 0.1351. That is equal to 0.6676, right? So how do you get this yi? 0.0449 divided by 0.1351. You get this yi. Okay. Similarly, you have to compute xi and yi for the entire all 6 data items, right? So shall I go to the next slide? See, now we are going to compute the normalized probability values. See, xi and yi. So how do you compute this xi and yi? So we have got it in this previous step. So I've just again rewritten it. Okay. So see, are you able to hear me? ஜியோ போனாலும் இங்க இதுல இருக்கு இதுல இருக்கும். So if you have any problem, you just tell me. There is a power shutdown here. Coordinators, host, please tell me whether you're able to hear me. Ma'am? Okay. Are you able to see me or hear me? Okay. Assuming that you are able to hear me, I'll proceed. So the next thing is, see, now we are going to compute the new mean for both the Gaussians. How do you compute this mean? See, here I have calculated sigma xi into xi. How do you compute this? This 0.6676 into 2 plus 0.5998 into 3 plus 0.326 into 7, so on. I've got this value 12.6208 and mu2 is equal to 20 point. So now again nx and ny we have calculated, and then we get this as, see, I've calculated this mean here 12.6208 divided by nx is nothing but 2.7309. You get this value 4.6214. Similarly, see here I have got it as 20.3792. Here 20.3792 divided by this normalized probability for Gaussian 2 will be 3.2691, that is 6.2338. See, I repeat, earlier we have assumed the mean value to be what? 4.6816 and 6.1836. Now we got this new value as 4.6214 and 6.2338. So again, we have to compute the new variance for both the Gaussians. This also I've told you earlier how you calculate it using these formulas, and you arrive at the new computed variance. So initial mean, initial variance, you can just go for a MATLAB code. You can implement this, and finally you get the final mean to be 3 and 8, and the final variance is 0.6667. So looking at this data set itself, see here, 2 plus 3 plus 4 plus, so what is the final mean? 2 plus 3 plus 4 plus 7 plus 8 plus 9 divided by 6 will be equal to, okay. So since we are grouping it into two clusters, two groups, we get the final mean to be 3 and another one to be 8, right? So final variance is 0.667. So you can just make use of any coding and find it out. So this is EM algorithm. So what is the relationship between EM algorithm and k-means clustering algorithm? So I've explained it to you clearly. The set of centroids in clustering corresponds to the set of means in EM, right? And k-means clustering corresponds to the mean estimation part of the EM algorithm. But in k-means, the samples are allocated 100% to the closest centroid. In EM, samples are shared between GMM components according to the posterior probabilities. So k-means clustering algorithm is a hill climbing algorithm where we will be searching for an optimal solution, right? So I repeat, the relationship between expectation maximization algorithm and k-means clustering algorithm, the set of centroids in clustering corresponds to the set of means in EM. K-means clustering algorithm corresponds to the mean estimation part of the EM algorithm. But in k-means, samples are allocated 100% to the closest centroid. In EM, samples are shared between GMM components according to the posterior probabilities, right? So, okay, we can just think of k-means clustering algorithm as a hill climbing algorithm. We must have studied in data mining itself. It is a hill climbing approach, like looking for an optimal solution, right? So, thank you. I just want a 5 minutes break. Next, we will go to the next topic, that is BPMN. So welcome again. So now we will be discussing on the two new topics, deep neural networks and backpropagation training algorithm. So is my screen visible? My PPT is shared? Please answer, one of you. See, are you able to see this new presentation? Okay. So this topic on backpropagation training algorithm, followed by deep neural network, I will be explaining you now. So we have already heard about this backpropagation training algorithm n number of times, but we nowadays the topic deep neural network is becoming very popular. See, what is this artificial neural network? Just a minute. So this artificial neural network, it is a mathematical model of biological neurons. Okay, the biological neural networks refers to a group of biological nerve cells that are connected to one another, and the network is used to transmit information between any 2 points. See, look at here. So you have a number of neurons connected, and actually the mechanism of human brain, many doctors are still doing research on the how the human brain works, but still lot of unanswered questions. Okay, so see, you have the dendrites here, you have the nucleus here, these are other dendrites, you have the axons, and the electrical signal is passed from one dendron to the another. Okay, so it is actually a mathematical model of biological neurons, and the biological neural networks refers to a group of biological nerve cells that are connected to one another, and it is used to transmit information between any 2 points. So see here, this is the artificial neuron, or you call it as the perceptron. Okay, so what is this? How this perceptron works? See here, this is the input layer, x1, x2, etc. up to xn. W1, W2 are the weights associated with these inputs, and net is nothing but the bias plus x1 into W1 plus x2 into W2 plus etc. up to xn into Wn. So out is a function of net, and there are different types of activation functions. See, it can be a step function, or it can be a sigmoidal function, it can be a tangent function. Out is equal to 1 if net is greater than or equal to the threshold, and if it is equal to 0 if it is less than threshold. So out is equal to 1 by 1 plus e power minus net is nothing but this is for a sigmoidal function. We have seen what is out. Okay, so net is nothing but you just multiply the input values with the weights associated, and out is a function of net. Right. So this you have to first of all understand. Then we'll go to the next slide. See, x1 into w1. So this is just a example of an artificial neuron or a single layer perceptron. Okay. So we know then we went into multiple layer perceptron. Then finally we started with backpropagation neural networks, and then we ended up in deep learning architectures. See here, net is nothing but B naught is the bias. This x1, x2, etc. up to xn are the input. W1, W2, etc. up to Wn are the weights associated with the inputs. And out is a function of net. And the activation functions, there are a number of activation functions. Here I've given you, this is the step function, this is the sigmoidal function. The step function, it can be either 1 or 0 if net is greater than or equal to threshold. And it is, if it is less than theta, it is 0. And that is 2 classes. Here out is equal to 1 by 1 plus e power minus net. This is the sigmoidal function, right? So what is this backpropagation neural network? As we all know, backpropagation neural networks, it is just resembling our artificial neural network, where it has an input layer, output layer, and one or more hidden layers. Okay. Okay, so now I've given you an example of a backpropagation neural network. How many layers are there? You just look at this diagram. How many layers are there? So in this, there is only one input layer, one output layer, and one hidden layer. Okay. So CRISP, I have given it in CRISP terms. See here, this is the input layer, this is the hidden layer, and this is the output layer. So what do you get? What do you give as input? The feature vectors. Suppose there are 10 features extracted from one image. You have how many nodes in the input layer? 10 nodes. Okay, x1, x2, etc. up to xn. Suppose you have 3 outputs. You have 3 nodes in the output layer. And the hidden layer nodes, you have randomly decide the number of nodes in the hidden layer. It is a fully connected network. It is a fully connected network. Sorry, it's a fully connected network where this x1, all nodes are interconnected to all the other nodes in the network. So what do you mean by this? See, x1 is connected to all the nodes in the hidden layer. X2 is connected to all the nodes in the hidden layer. And see here, this node in the hidden layer is connected to all the other nodes in the output layer. So you call it as a fully connected network. I repeat, this is the input layer. Very carefully you listen. So deep learning is nothing but it's just an extension of backpropagation neural network where you have the number of hidden layers to be very, very large. So when you increase the number of hidden layers, automatically your network gets trained to a greater extent and your classification accuracy becomes very large. Okay. So see here, this is the input layer, this is the hidden layer, this is the output layer. It's a fully connected network where all the nodes in the input layer and the hidden layer are connected to all the other nodes in the hidden layer and output layer respectively. You can increase the number of hidden layers as per your application, and you can study the performance of the network also. Okay. So see here, these are the weights associated with the input layer. These are the weights associated with the hidden layer, and this is the output. Again, I repeat, this W11, W12 are all the weights associated with the input layer. Input layer, we have n number of nodes where n is nothing but the number of dimensions or number of features extracted from a data item. So this W11 is nothing but the weight associated with X1, that is the first node in the input layer and the first node in the hidden layer. W12 is the weight associated with the first node in the input layer and the second node in the hidden layer. See, this is the weight associated with the second node in the input layer and the first node in the hidden layer. See, you people just keep on wait in the waiting room and you're distracting my presentation. Okay, see here, there are two passes actually, two phases actually, forward pass and the reverse pass. Okay, so in the forward pass, you just keep on calculating the net and the out, just like what you have done here in the perceptron. See here, net is nothing but bias plus summation of x1 into w1 plus x2 into w2 plus etc. up to xn into wn. And then out is just a function of net. So simple. This is the forward pass. In the reverse pass, there are two actually weights to be calculated. First is output layer, the weights to be calculated in the output layer and the weights to be calculated in the hidden layer. That is, you have to calculate V11 and W11. So only these two constitute the reverse pass. So forward pass is nothing but you just keep on calculating the net and the out. Whereas in the reverse pass, you backpropagate the error. By backpropagating the error, you recalculate the weights. Recalculating the weights is nothing but there are two possibilities. One is recalculating the weights in the output layer and the other one is recalculating the weights of the hidden layer. Okay. So how do you recalculate them? If you know just these two things, then you are done with this BPNN backpropagation training algorithm. See here, delta QK is equal to, okay, out into 1 minus out into target minus out. That's all. This is for output layer. New weight is equal to old weight plus eta into del. Eta is nothing but the learning factor. Eta into delta into out. So this you shouldn't forget. This is calculating the weights of the output layer. This is finding the weights of the hidden layer. See, I repeat, output layer is nothing but delta is equal to out into 1 minus out into target minus out, and new weight is equal to old weight plus eta into delta into out. So here for hidden layer, delta is equal to out into 1 minus out into whatever comes in this node. See, delta qk, that is the error which we obtained here, into the previous weight. Okay, so whatever comes here, the error which comes here into this, error which comes here into this, error which comes at this node into this. So this is the same procedure, only thing is the notations will be a little bit confusing. Otherwise, it is a simplest algorithm. See, old weight is equal to new weight plus eta into delta into x here, xm. See here, this is because this is adjusting the weights in the hidden layer. This is adjusting the weights in the output layer. There are only two phases in the reverse pass. Forward pass, you just keep on calculating the net and the out, whereas in the reverse pass, you adjust the weights of the output layer and the hidden layer. Okay. So it is so simple only. Only thing is, if you work out with a simple algorithm or simple problem, you'll understand it more better. Right? Huh? So the next thing is, see here, deep learning. So deep neural network is an artificial neural network with multiple layers between the input and the output layers. See here, see, this is a simple neural network wherein you have input layer, hidden layer, output layer. See here you have, this is one input layer, this is output layer. How many number of hidden layers you want, you can extend it, right? It uses backpropagation training algorithm to adjust the weights in the network, okay? So deep neural network is an artificial neural network with multiple layers between the input and output layers. And it is just an extension of backpropagation training algorithm. It uses backpropagation training algorithm to adjust the weights in the network. So this is a simple neural network. This deep learning neural network where you have a number of hidden layers in between the input layer and output layer. Input layer, the number of nodes corresponds to the number of dimensions, that is the number of features extracted from the object, and output layer corresponds to the number of categories. The number of nodes in the hidden layer you can vary to study the performance of the backpropagation network. So it is just an extension of BPNN. Only thing is, it makes use of backpropagation training algorithm for training and testing. So this is again a supervised learning algorithm. See, there are these Python package indexes, that is, if you want to learn something about pip install, you can just go for PyPI in this website. And there are some Python packages for image processing. You can just try them, OpenCV Python and Scikit for image. And for machine learning, Keras and Pandas are there. And you can just install Anaconda in your system, and you can make use of any editor, Jupyter Notebook or anything, and pip install OpenCV Python and pip install Keras for this machine learning and deep learning. And you can run any algorithm. See here, this is an MNIST database, that is Modified National Institutes of Standards and Technology database. It is actually a large database of handwritten digits. You have to identify this handwritten digits, that is classification. 0, 2, 4, 3, these are handwritten digits, this BPNN algorithm, or you can use deep learning also. See, I've given you the coding using Python. When you are free, you can just run this coding. I've explained you what at each epoch, how you get the accuracy. So I've given you the chart for epochs versus accuracy also. And you can refer the Sholet book for deep learning with Python. It's a very good book. And these are certain libraries. And that's it. I think with this we can stop. Ma'am, any questions? Is it muted? No, I've not muted it. Hello, ma'am. So if you have any questions, you can ask me. Otherwise, we can stop. If you have any questions, you can raise. Otherwise, we can stop. So you can go through this coding whenever time permits. So you can just copy this, paste it into your Jupyter notebook or any other editor, and automatically this coding will run. So this is an MNIST database which I've taken, and you can run this coding. You can increase the number of layers also, increase or decrease the number of layers. Any other questions, you can ask me. Shall I leave the meeting?